everyone, welcome back to my channel. This video is a complete tutorial on an artificial intelligence and machine learning. In the first half, we'll learn all the fundamentals of an artificial intelligence, whereas in the second half, I will discuss all about machine learning. So let's get started. An artificial intelligence is a very important topic in current scenario. That's why let's learn all the fundamentals of an AI. We will be covering AI agents, AI chatbots versus AI agents, generative AI, GANs, LLMs, prompt engineering, tokenization, transformers, RAG, hallucination, fine-tuning, MCP, multimodal AI, mixer of experts, and vibe coding. So without further ado, let's start our video. Let's start with AI agents. I think you have already heard this term before because AI agents are such a hype in tech industry now. Now let's learn how do AI agents function, what are the applications of it, and so on. So without further ado, let's get started. AI agent is an intelligent system that can interact with its environment, such as engaging in surrounding to gather necessary information. It can also gather data from environment for decision-making process. Another feature of AI agent can be analyzing data to make informed decisions autonomously. Similarly, AI agents can execute information independently to achieve a specific goal. Therefore, in summary, AI agent is an intelligent system that can interact with its environment, collect data, make decisions, and take actions with little human intervention or completely autonomously to achieve specific goals. In simple words, it takes our input and process it and gives an intelligent output. AI agent, they can learn, adapt, and act autonomously. They can process multiple information like text, video, audio, and voice simultaneously. The examples are chatbots like ChatGPT, self-driving cars, smart home assistants like Alexa or Siri, AI-powered recommendation systems like Netflix and Amazon. And interestingly, these AI agents don't just respond, but they think, plan, and improve over the period of time. Let's look at the real example. Suppose you want to have a dentist appointment. For that, when you use personal AI assistant like Siri or Alexa as a learning agent, first you say like, "Hey Siri, make a dentist appointment for Monday at 3 p.m. Then, let's see how AI agent works in this scenario. First, the request from the user is accepted and it starts the booking process. Then the next step is it finalizes the best fit date and time for the user. And at last, it confirms the appointment date and sends notification to the user. Therefore, AI-driven appointment workflow looks like this. The first is input, where it listens to your voice by speech recognition. The second is the process, where it understands the context and check available dates on the calendar. And the third is an action, where it makes an appointment, sends confirmation, and adds it to the reminder. Next, we have component of AI agents. The AI agents components are sensors or inputs, processors or decision-making engine, memory or the knowledge base, and the actuators or the outputs. Now let's discuss each of them. The first is sensors or inputs. So this is how an AI agent perceives its data. The sensors can be temperature sensor, where it measures and monitors the temperature changes, and similarly pressure sensor, where it detects and measures pressure in various systems, and another it may be light sensor, where it captures and analyzes light intensity and presence, and similarly motion sensors can be, where it detects movement and trigger automated responses. Another component of AI agent is the processor or the decision-making engine. The processor or the decision-making engine is the brain of an AI agent. They process information from the sensors or the input. They utilizes the different models and algorithm and gives the best possible outcome to the actuators. The third one is memory or the knowledge base. This part of AI agent stores data which helps in completing tasks. It can also store past data or any complications and its solution to enhance the AI task completion. The last component of an AI agent is actuators or the outputs. This shows how an AI agent acts. It can have output in any form such as physical actions like robotic movements and environmental controls, and the digital results like data manipulations, or the control over software commands. Similarly, the output may be in the form of communications. Next, we have is types of AI agents. There are various types of AI agents. Each agent suits to different applications depending on how smart or capable they are. Now let's learn each AI agent. Simple reflex agents are the simple agents that are based on the current environmental state and react to basic inputs. They do not hold any memory and they are pre-programmed to perform certain tasks. The example of this is turning light on when some motion is detected. Next type of agent is model-based reflex agent. The model-based reflex agents use both the internal memory of the past event and current perception. If it gets new information, the model is updated and predict the future result accordingly. Example may be traffic prediction. The goal-based agents work with a specific goal or set of goals. They search for different action sequences that help in making decisions to reach their goal. The example can be chess playing agents. The utility-based agents consider a sequence of outcomes that can reach the goals and choose the ultimate outcome in order to make the maximum benefit or reward. The example can be a navigation system that optimizes the route to destination considering the time and cost of the fuel. The last one is learning agents. The learning agents improve their performance over time by learning from experience. New experiences are added to the initial knowledge and improve the output. The example is the recommendation system on various e-commerce sites. The real-world applications. AI agents are everywhere and they are already making a great impact across different industries. Suppose the healthcare. AI agents in health sector are used to analyze medical reports, assist in disease diagnosis, medical data management, assist in treatment personalization, and are used to perform different routine tasks. AI agents in education. It can be very important. The AI tutoring systems can provide great learning experiences. For example, focus on teaching, which allows educators to concentrate on instructions. Similarly, it can enhance engagement, increasing student interest and participation. It can also automate different tasks such as administrative duties. Another important thing we can do with AI agent is that we can personalize learning by adapting to individual student needs. AI agents in finance. It can help in fraud detection, such as identifying or preventing fraud activities. It can also help in risk management by various financial assessment and risk analysis. Another thing is that it can also be used for trading services. And the last one is it can be used in customer services to provide financial advices and supports. AI agents in manufacturing can optimize production process through automated process, enhancing efficiency. Similarly, it can be used in quality control, ensuring product is standard through AI-driven checks. Another is it can be used for predictive maintenance such as forecasting equipment failure to prevent downtime. Similarly, AI agents can be great for supply chain optimization, handling logistic and inventory management. AI agents in transportation can be used for autonomous vehicles, enhancing safety and efficiency. Another application is traffic management in order to optimize traffic flow. Next we have is AI streamlining logistic and supply chain in transportation. The last one is in public transportation to improve public transport reliability and accessibility. Therefore, the application of AI agents can be in various industries. Very soon, it could be our financial advisor, data agents, personal tutor, code reviewer, or legal advisors, and many more. AI agents are important because they help in reducing human workload and make life easier. They can learn continuously and improve over time. They help in efficiency enhancement by automating tasks and improving their speed and accuracy. AI agents matter because they boost the productivity by handling the repetitive task. Similarly, AI agents provide data-driven insights to make better decisions. Next is AI agents can be adjusted to the changing environments. Therefore, they matter to us because they are transforming various industries in the near future. AI agents are applied in different fields to make life easier, but on the other side, it comes with various challenges to deal with. For example, bias and discrimination. AI agents should be fair to all the circumstances, but if they are trained on bad data, they can make bad decisions. Therefore, we should be careful on it. Another challenge can be of privacy and security risk. As we know that to build any AI agents, we need a lot of private data of users. Hence, it can be challenging to control the privacy of users. Next challenge can be lack of accountability and transparency in AI decisions. The other concerns can be of significant job displacement. Hence, there can be so many concerns such as morality of an AI agent or how they behave in complex decision-making conditions in health sector or how they act in unpredictable environmental crises and so on. Therefore, we need a responsible AI development in order to deal these issues. Okay, that's all for understanding AI agents. We learned that AI agents are intelligent systems that are already all around us and they are going to work side by side with us in near future. Today we are going to learn what are the main differences between AI chatbots and AI agents. Let's dive into our video. AI chatbots and AI agents both use artificial intelligence, but they are not exactly the same. So let's break down the key differences between them and see which one is smarter. The purpose of AI chatbots are primarily designed for talks or conversational interactions, which means they are made for chatting and answering questions. Example is like for customer supports or FAQs. Whereas the purpose of AI agents are designed to act autonomously and accomplish complex tasks. Example is like writing code and executing. Autonomy. AI chatbots are reactive. They follow and respond according to the user prompts, whereas AI agents are proactive. That is, they make their own decisions and take actions. Memory and context. AI chatbots have short-term memories or session-based memories, but AI agent can have long-term memory and it has better context awareness because it learns over time. Learning capability. AI chatbots use static NLP models and need manual updates, whereas AI agents use machine learning, reasoning, and can self-improve with reinforcement learnings, so it gets smarter over time. Integration power. AI chatbots interact via text or video within a chat interface, and it may connect to few APIs or databases. Whereas AI agent works across the tools and integrate with APIs and different database and tools. Problem solving. AI chatbot can answer simple questions and follow scripted responses, whereas AI agent they can break down the task and follow multi-step workflows and solve problems. The use cases. Use cases of AI agents can be personal AI assistants, self-driving cars, trading bots, and so on. The use cases of AI chatbot are customer service bots, FAQ bots, chat supports, and basic queries, and so on. Multimodal capacity. AI chatbot is based on text or video communications, whereas AI agent is based on communication through multimodal data such as images, videos, real-time data, or sensor data. Okay, that's all for the differences between AI chatbots and AI agents. We came to know that chatbots are typically used for conversational interfaces, whereas AI agents go beyond this and make decisions and solve complex workflows autonomously. So what exactly is generative AI and why it is such a big deal right now? Let's break it down in this video. Generative AI or Gen AI is equal to an AI that creates. The proper definition of generative AI is it is a type of an artificial intelligence that can create new content such as text, images, videos, music and more just from user's prompt, and it can also use what it knows to solve new problems. It can learn languages, arts, physics, chemistry, biology or any complex topics. For example, I am typing something like a dog wearing a sunglasses and riding a bicycle. So this prompt can generate unique images in seconds. That is generative AI at work. Generative AI creations. The creative power of generative AI is large. For example, Gen AI can generate text such as articles, emails, poems, stories, codes, and so on. It can generate images like artwork, photos, or logos. It can also generate audios such as songs, voice, music, and many more. Gen AI can also generate videos such as short clips, animations, and many more. We can easily write new code in Python or JavaScript or for different websites. Gen AI is able to create 3D models as used by different game environments and architectures and so on. Therefore, these are the creations of generative AI, and it is growing day by day in various forms. So now let's see how Gen AI is different from regular AI. The traditional AI is built to recognize patterns and make decisions. It is great at analyzing. The example is like recommendation systems. However, the generative AIs, it goes a step further. That means it uses its earlier knowledge to create something new. Example is like writing an original poem that never existed before. Now, let's understand how Gen AI works. In fact, generative AI relies on neural networks, deep learning algorithms, and machine learning models, which trains on large language models, LLMs. Now, let's understand each process. Building the blocks. For this, we have data and the models. The data is the huge collection of text, images, books, articles, music, and so on. Whereas the models are the complex mathematical structures like deep neural networks, and these models learn patterns in huge database. Pre-training. Gen AI starts by training on the massive amount of data such as articles, books, images, websites, and many more. It learns statistical patterns and structure from this huge set of data. For example, while training on text, it can learn how words and sentences are arranged together. Similarly, while training on images, it can learn the shape, size, color, and so on. Neural networks. Gen AI used the neural network model inspired by the human brain. Neural network consists of neurons, which is layers of interconnected nodes, and each neuron processes various inputs and give the output for the next steps. Every connection has something called weights. This is to make better prediction and generate output. Fine-tuning. After general training, models can be fine-tuned for a specific task. For instance, a language model fine-tuned to summarize any text or write poetry. Similarly, image generator fine-tuned to create animation-style images. Generating content. The first step is prompt engineering. Then Gen AI model is trained to generate new content. For example, when we give a prompt like today it will rain, then AI uses what it has learned to predict what comes next, like today it will rain heavily. Different models use different techniques. There are two popular models in generative AI that are transformers and generative adversarial networks, that is GANs. GPT model use transformers and attention mechanisms to predict the next word of a sentence, whereas GANs use two models. One is to create and the other is to analyze, thus creating realistic images. Use cases of generative AI. Let's see what are the real-world use cases of generative AI. Healthcare. Gen AI can be used in healthcare for medical image analysis, medical research, disease diagnosis, and so on. Education. It can be used for personal tutor, for automation in exam, material preparation, and so on. Marketing. It can be used for social media, ad, product design, and so on. Customer service. Different chatbots can help to answer the questions from customers. Therefore, Gen AI is used in many fields. Challenges of generative AI. Generative AI is still in progress. There are so many challenges. Bias in outputs. AI models can produce biased results. Ethical concerns. There are so many ethical concerns around AI uses. Accuracy issues. There are accuracy issues also, as Gen AI can hallucinate. Copyright and ownership problems. So there are problems like who owns AI generated content, the user or the company. There is still a legal gray area in many countries, so copyright and ownership problems should be solved. Lack of reasoning. AI is all like pattern prediction, so it doesn't understand context and can lack realistic reasoning. Now let's understand the difference between generative AI and agentic AI. Generative AI, Gen AI, is a type of artificial intelligence focused on generating new contents like text, images, or even videos. Gen AI utilizes huge amounts of training data to understand the patterns or the structures and then generate outputs based on what they have learned. For example, ChatGPT creating a new contents. Agentic AI is a form of an artificial intelligence that uses deep learning to solve issues autonomously and make decisions based on its objectives. It operates independently of continuous human guidance and responds to changes in order to achieve specific goals. For example, self-driving cars can make real-time decisions to navigate road and reach the destinations. The difference between generative AI and agentic AI in terms of objective is generative AI is designed to produce novel content based on training data and user prompts. It is great at completing tasks such as generating images, code, text, or even composing music. Whereas the objective of an agentic AI is to focus on decision making and complete complex tasks. It has to interact with tools, environments, or other systems to achieve predefined goals without human intervention. For example, if we ask ChatGPT to write a blog, then it writes. That is generative. But if we ask an agentic AI to publish that blog, it could do everything such as log into the blog, do some changes, and then hit publish, all without any input from us. Technology used. Generative AI relies on generative adversarial networks, GANs, and transformer models, example GPT or the bot, to produce new content, whereas agentic AI relies on reinforcement learning, decision trees, robotic frameworks, and sensors to perform tasks. Output. Generative AI produces typically creative content such as text, articles, images, music, designs, code, and other forms of data, whereas agentic AI gives output like decisions or an actions on problem solving to meet particular goal. Autonomy. Generative AI is reactive. It responds to our prompts but does not plan ahead or make decisions without our guidance. Whereas agentic AI is proactive. It can set sub-goals, make decisions, and adapt if something changes in its environment. A generative model can summarize articles for us, whereas agentic model could read 4 articles, analyzes them, summarize the differences, and send that report to our email. Applications. The applications of generative AI can be in the field of content creation, research, documentation, creative industries, medical research, coding, translation, marketing, product design, customer support, and so on. Whereas the application of an agentic AI can be in industry automation, project management, robotics, autonomous vehicles, cybersecurity, healthcare assistance, financial trading, investigation, and so on. Examples. The example of generative AI is ChatGPT, Gemini, DALL-E, Runway ML, and so on. Whereas the example of an agentic AI is Alexa or Google Assistant or Tesla, and so on. User interaction. Generative AI requires user input, prompt engineering to generate useful and fresh content, whereas agentic AI acts upon one. They do not require continuous user interaction. It can interact with outside environment and gather information to achieve goal in real time, as in self-driving cars. Impact. The impact of generative AI is it is great for content creation, information accessing, and it supports information technology field. Whereas the impact of an agentic AI is it is great for automation and it increases productivity by minimizing human intervention. Limitations. The limitations of generative AI can be there must have good quality of training data and it should produce correct and unbiased outputs, whereas the limitations of an agentic AI is it can be difficult to implement complex data while training. Similarly, it requires proper ethics and security to make proper decisions. we have learned Gen AI is great to brainstorm or create, while agentic AI is built to act, execute, and get results often without needing any help in every steps. And combining both the creativity of Gen AI and the autonomy of agentic AI is where the real magic starts to happen. Now, let's understand a brief history of generative AI. As we know that generative AI is based on machine learning and deep learning algorithms, so let's go back and discuss the timeline. It all starts in the 1950s, the foundation of AI or the early days of an artificial intelligence. In 1950, Alan Turing publishes the paper called Computing Machinery and Intelligence. This paper introduces Turing tests that analyze the machine's ability to exhibit intelligent behavior like a human. So this concept became philosophical base for an artificial intelligence. In 1957, Frank Rosenblatt, a psychologist from Cornell University, developed perceptron, the world's first neural network that can be trained. In the 1960s, the world's first chatbots has started. In 1964, Joseph Weizenbaum at MIT Artificial Intelligence Laboratory created ELIZA, the first chatbot. It was a computer program that can have conversation with a human by using a natural language and generate text responses. It was an example of generative AI. In 1980s, different research in natural language processing, artificial intelligence, and machine translation has happened. In 1982, Recurrent Neural Network (RNN) was developed by John Hopfield. This RNN can learn and remember patterns. 1990s, AI in machine learning and problem solving. In 1997, the idea of long short-term memory (LSTM), an advanced form of recurrent neural network (RNN), was proposed. This neural network allows efficient processing of long sequences of data which are important for generative tasks such as speech recognition. 2000 is the era of revolution in deep learning. In 2004, Google's autocomplete was released, which predicts next potential words as users enter their search words. This was based on a mathematical model known as Markov chain. In 2006, Geoffrey Hinton introduced deep belief networks, that is DBNs, based on deep learning and unsupervised pre-training. 2010s is the era of virtual assistants and chatbots. In 2011, Siri with iPhone 4S by Apple was introduced. The first virtual or NLP assistant was functional. This used predefined command to take questions and answer them. In 2013, a generative model called Variational Autoencoders (VAEs) was created. In 2014, the first generative adversarial networks (GANs) was appeared. It is a class of machine learning that can generate new data according to training data set. GANs are used to create images, audios, and videos that look like authentic. GANs are breakthrough in Gen AI as they produce high-quality images and videos. In 2015, diffusion model was introduced. This process incorporates noise to the original training dataset and use reverse denoising process to restore the data. In 2017, transformer architecture was proposed by a team of Google led by Ashish Vaswani. This model used a self-attention mechanism and also weighed the importance of various input sequences when processing. Transformers became the foundation for models like BERT and GPT. In 2018, OpenAI introduced a large language model called GPT, Generative Pre-trained Transformers. In 2019, OpenAI releases the complete version of GPT-2, which was trained on more dataset. 2020s, GPTs and multimodal models. In 2020, OpenAI introduced GPT-3, capable of generating human-like text, coding, and responding FAQs. In 2021, OpenAI launched DALL-E for generating images from textual descriptions. In 2022, open-source Stable Diffusion and Midjourney AI was released, that is high-quality image generating text-to-image tool. Similarly, in 2022, ChatGPT releases GPT 3.5, a conversational AI interface accessible to the public. This tool can access data from the web up to 2021. In 2023, OpenAI releases GPT-4, capable of generating longer text up to 25,000 words and with better reasoning. Google also introduced AI chatbot named Bard. In 2024, various multimodal agents LLMs such as Gemini 1.5, Sora, Cloudy 3 were released. In this manner, generative AI has come a long way, from basic rule-based machines in the 60s to an advanced creative AIs in the 2020s. It has become a powerful tool transforming how we work, create, and think a task. And this is just the beginning. Why is it a game changer? Generative AI is a game changer because before generative AI, making any content would have taken long hours and many skills. But now, even if you are not a designer or a developer, you can create amazing stuffs in no time. It is helping programmers to write code faster, designers to come with lots of design ideas, faster results in business, and so many other advantages like never before. So in short, generative AI is creative. It is helping people around the world turn ideas into reality and more faster, cheaper, and easier. Today we'll learn about Generative Adversarial Network, that is GANs. So let's dive in. Generative Adversarial Networks (GANs) are a class of deep learning architecture used to generate realistic data by learning patterns from an existing datasets. GANs are introduced by Ian Goodfellow in 2014. GANs are considered as one of the most exciting breakthroughs in AI as they have transformed how computers generate high-quality images, videos, and realistic data. GAN train two different networks to compete against each other. One network is generator. This is to generate new data, while the other is discriminator. This is to evaluate whether the generated data output belongs to the original dataset or not. Architecture of GANs. In order to understand GANs, we must first understand the two models, that is generator and discriminator, which works together to create realistic data. Now let's understand what is the generator. The generator is a convolutional neural network. The generator takes random noise as an input. The goal of generator is to artificially generate fake data like image or text that resemble real data. Its objective is to fool the discriminator and produce samples that the discriminator classifies as real. Next we have its discriminator. The discriminator is a deconvolutional neural network. The discriminator takes real data and fake data as an input. The objective of discriminator is to identify between the real data and artificially generated data. This model learns to improve by continuous training and updating its parameter to detect fake data more accurately. How GAN works? So this figure indicates the structure of GAN. Now let's see how the training process in GAN happens. Now let's learn how the GAN works actually. The training process. First we have the initialize. The generator is given random noise as an input and the discriminator is given real or the ground truth data and fake image as the input. Next is the training the discriminator. The discriminator has both real and fake data as an input. The discriminator calculates the output probability, a value between 0 and 1, where 1 indicates the real data and 0 indicates the fake data from the generator, and it updates the weight to distinguish properly. Now is the process of training the generator. The first is generate fake data, and then it is passed to the discriminator. If the discriminator is fooled, then generator improves. So with many repetitions, generator improves its output. So this is iteration process. Both the networks, generator and discriminator, are trained simultaneously in a loop. The generator improves at producing realistic data, and the discriminator improves at telling the real from fake. Therefore, this process of training continuously until the discriminator can no longer tell real from fake. That means the generator has become highly accurate. Types of GANs. There are several types of GAN models depending on how the generator and discriminator interact with each other. All GANs are developed to address a specific task. These are some important ones. Now let me explain each one. Conditional GAN or CGAN adds an additional conditional parameter to control over output generation by using labels. Therefore, the input here is noise and label. The objective here is to allow the model to produce certain type of output rather than generating random output. The example is CGAN can generate a specific object like a dog or the cat according to the label provided. Vanilla GAN. These are basic model of GANs. It consists of generator and discriminator involved in typical adversarial game. It needs to be more enhanced for handling real-world applications. Deep convolutional GAN, that is DCGAN. This uses a deep convolutional neural network for better image generation. They are popular for generating high resolution and realistic images. Cycle GAN. This type of GANs are used to learn how to transform images between various styles by using unpaired datasets. For example, a model can be taught how to alter an image from a horse to a zebra or vice versa. Style GAN. It is developed by NVIDIA researcher in 2018 and it produces high quality and extremely realistic photos of faces, artwork and more. They are trained by using a dataset of images of same object. Super Resolution GAN. It is designed to upscale low resolution images to high resolution images. This model improves image resolution by adding finer details to make more realistic and sharper. Use cases of GANs. GANs are widely used in various industries where data generation or data transformation is needed. Some of examples are image generation, image-to-image translation, object detection, medical imaging, image super resolution, data augmentation, game design, text-to-image generation. So these are the use cases of GANs. Okay, that's all for generative adversarial networks, GANs. We get to know that GANs are remarkable innovation in deep learning. It has revolutionized AI, research and various applications. Today we are diving into one of the most popular technologies of our time, that is large language models, which is also known as LLMs. By the end of this video, you'll have a clear understanding of what LLMs are and why they are important. So without further ado, let's get started. So what are LLMs? A large language model or LLM is a type of advanced artificial intelligence system. LLM is a computer program trained on vast amount of data, hence it is named as large. It learns patterns, structure and meaning of a language. Therefore, it generates human-like responses. LLMs are built on a type of neural network called transformer model. LLMs can perform translation, summarization, coding and much more. The examples of LLMs are ChatGPT, Gemini, Llama, Cloudy and so on. Now let's see how LLMs work. Actually, LLMs are built on type of neural networks called transformer architecture. So here are the simple process of how LLM works. The first is collection of huge amount of text data. That means LLMs are trained on huge amount of text data either from books, articles, websites and so on. Next step is data cleaning. So before training the model, first there is a cleaning of data such as removing duplicates, low quality content, wrong data and so on. Another is tokenization. In this process, texts are split into smaller units called tokens. For example, I love coding will be splitted like I love coding. Next step is embedding, which means each token is converted into a numerical vector. Attention mechanism. This is very important part of using transformers. Here the model looks to all the sentences, words or figures and pays attention to the most important part of a sentence. For example, in a sentence, a boy fell asleep because he was tired. Here he refers to a boy. So this is the attention mechanism. Next is training on data. During the training, the model processes billions and trillions of data, predicting next word, and if it is wrong, the model corrects its knowledge by referring its huge data, and this process is repeated until the model learns proper patterns, creativity and reasoning. The next step is fine-tuning with human feedback. That means after the training process, humans give feedback, so it learns to give safer and more better answer. The last step is inference. Once our model is trained, we can give prompt to the model and then it generates our response by predicting words one by one. For example, Tokyo is in, then it will predict Japan. What are LLMs used for? LLMs are used in chatbots and virtual assistants. They are used for answering customer queries, performing back-end tasks, and providing various information to users as a part of customer services. LLMs can generate code according to user instructions and can also perform debugging if required. These days, some LLMs can perform sentiment analysis to help users to find customers' intention or a response. LLMs are used for language translation. If LLMs are trained on various languages, it can break the barrier among multilingual environment. LLMs are used for summarizing multiple pages of articles, news, research papers, and so on. Here are some of popular LLMs recently. OpenAI GPT family such as GPT 3.5, GPT-4. Google's DeepMind Gemini, which excels at long context reasoning. Meta's open source model, which are widely used by researchers. Anthropic's Cloudy, which is known for safety-focused design. Google and Facebook's BERT and Robert are good at embedding and understanding tasks. Mistral, which is popular in open source communities. Therefore, they are some of the popular LLMs recently, and each LLM has its own strengths and benefits. Advantages of LLMs. Scalability. LLMs can handle enormous amounts of data. Continuous improvements. LLMs can learn and adapt new data continuously and improve the performance as they are fine-tuned. Flexibility. LLMs are versatile. That is, one LLM can be used for different tasks such as translation, summarization, text generation, and so on. Efficiency. LLMs make our life easier as they automate our routine tasks. Easy on training. Many LLMs are trained on on-level data, so it is less time consuming. Hence, these are some of the advantages of LLMs. Now let's see the disadvantages. Disadvantages of LLMs. Despite many benefits of LLMs, they have some limitations too. Data privacy risk. LLMs process huge amounts of data. If there are some sensitive data, the model should ensure its confidentiality. Hallucinations. Sometimes LLM can provide false information with confidence, so it may cause problem. Bias. Since LLMs are trained by humans from many sources, they may reflect biases in those data. High operating cost. Cost of operating LLM can be high as they are trained on large amount of data and can require expensive computing power. Ethical concerns. LLMs may have issues on data plagiarism or malicious purposes. Why LLMs are important? LLMs make knowledge easily readable and accessible than earlier days by summarizing long and complex topics. They allow people to use natural language instead of complicated commands. With LLMs, we have powerful tools such as chatbots, AI assistants, and much more. LLMs allow computers to interact in more natural way with humans. Therefore, in this way, LLMs are very important to us as they bring technology more closer. We understand LLMs are AI systems designed to understand human language, and they work using transformer neural networks and large amount of data. They are important because they are one of the most revolutionary technologies of our era. In this video, we'll explore what prompt engineering is and why it matters. We'll also learn how to provide better prompts to get best responses from ChatGPT. So let's dive in. What is prompt engineering? Prompt engineering is the art of designing inputs that optimizes AI-generated responses. A prompt is just a text input that is given to a large language model. So, it reads the prompt, it predicts the next tokens, and it produces one output. Now, let's see why prompt engineering actually matters. It matters for an efficient responses, and that means a clear and well-explained prompt reduces the need for multiple prompts. Another is for better accuracy. That means a well-structured prompts can lead to more precise answer or responses. Next we have is control over our output. That is, we can easily guide ChatGPT to produce a desired format or structure of our answer. Now let's discuss some key techniques for effective prompts. Technique 1. We should be specific. For example, a weak prompt is like write a summary about AI. Now let's write this in ChatGPT. Write a summary about artificial intelligence. Enter. See, we get the definition about artificial intelligence and what is narrow AI, general AI, and what is like modern AI by deep learning and the machine learning. So this is a general definition of artificial intelligence. So if we will be more specific, then we get better responses. So for this, the strong prompts will be like summarize artificial intelligence in 5 bullet points, focusing on its impact on technology, finance, healthcare, education, and entertainment. So it will be more specific. So let's write this in ChatGPT. Summarize artificial intelligence in 5 bullet points, focusing on its impact on technology, finance, healthcare, education, and entertainment. See, we get this specific answer like how AI is applied in different industries. Hence, we have to be more specific to get the better response from ChatGPT. Another key techniques for an effective prompts is by providing background information to ChatGPT in order to generate more relevant answers. For example, if we have to write an email, the weak prompt may be write an email. So this is not providing any context. That's why it is weak prompt. Now let's see what happens if we ask ChatGPT to write an email. Let's write an email. Enter. See, it is also confused because it doesn't know what kind of email do we want to write. Therefore, for a strong prompts, we should provide the context like write a formal email to my senior manager requesting a leave for 2 days due to poor health condition. Here, the second prompts add more context like formal email, 2 days off, poor health condition. Therefore, it ensures more structured response by ChatGPT. However, the first prompt, it fails to do so. Now let's go and write this in ChatGPT. Write a formal email to my senior manager requesting a leave for 2 days due to poor health condition. Okay, this much. See, we get the proper email to senior manager. So this is more better than our earlier response. Therefore, we provide context like this in ChatGPT. Next technique for an efficient prompt is we can set a role for ChatGPT and we can instruct it to behave like a teacher, software engineer, researcher, or any role to get the better response. For example, X is a Python developer and explain list with a simple example. So let's write this in ChatGPT. Act as a Python developer and explain list with a simple example. Okay. See, we get the definition of list with its example code. Here, ChatGPT adopts the mindset of Python developer, making the explanation more reliable and efficient. Another technique is to mention the output format. That is, if we need a table, code, or any format, we can easily mention that in ChatGPT. For example, the weak prompts can be like, tell me about the benefits of doing meditation. Now let's go and write this in ChatGPT. Tell me about the benefits of doing meditation. Okay, so this gives me the benefit of doing meditation. So this doesn't have any format. Therefore, if we want to give format to ChatGPT, we can do so. Therefore, the strong prompts will be like list 10 key benefits of doing meditation in bullet points. Now let's go and write this prompt in ChatGPT and see the answer of it. List 10 key benefits of doing meditation in bullet points. Enter. Okay, here are the 10 key benefits of doing meditation. Therefore, it gives all the 10 points. Advanced prompting method. Earlier, we learned simple and better way of prompting. Let's see some example for advanced style prompting method. First technique is chain of thought style prompting. That means it's like asking ChatGPT to think step by step in order to improve response in more logical way. For example, if we ask explain how to solve a quadratic equation step by step. Now let's go and write this in ChatGPT. Explain how to solve a quadratic equation step by step. Okay. See, this gives the solution to solve a quadratic equation step by step. Therefore, this technique provides more structured explanations rather than a direct answer to our prompt. Another advanced prompting method is multi-turn prompting. So, if the first response is not perfect, we refine it with another better prompts. For example, we can ask ChatGPT to summarize the history of the artificial intelligence. Let's see the response. Summarize the history of an artificial intelligence. Okay. See, ChatGPT, it responds by giving general history of an artificial intelligence as its answer. But if we ask like would you give more detailed answer with key milestone type of question for ChatGPT, then it will give more better answer. So let's see. Would you give a more detailed answer with key milestone? Okay. Here it gives more detailed history of an artificial intelligence with its key milestone. Look, all the dates and new like invention, deep learning, machine learning, Gen AI, modern AI, and all these things. Therefore, this kind of approach gradually improves the answer of ChatGPT for better results. Next is we can also perform advanced prompting by providing certain examples and guide ChatGPT to get the desired response. For example, we can write like translate the following sentences to Japanese, like what is your name, how old are you, where do you live. Let's go and write this in ChatGPT. Translate the following English sentences to Japanese, and what is your name, how old are you, and where do you live. Okay, this is our answer. See, it translates all. Therefore, this type of prompts will train ChatGPT to maintain the consistency in its response. Next is mistakes we do in prompt engineering. The first is asking too many things at once. That is, a weak prompt can be like explain Java, Python, and MATLAB, their features, applications, and pros and cons at once. So let's write this and see. Explain Java, Python, and MATLAB, their features, applications, and pros and cons. See, it starts giving definition of Java application, and it again gives the same for Python and MATLAB. But we have asked so many things at one time, that's why it is not giving the proper and detailed answer. Therefore, to fix this, we can break this whole prompt into smaller prompts to get the better answer. Like, we can simply ask explain Python and its features only. See, we get more detailed explanation of Python and its features and some codes also here. Advantages, limitations, and so on. So this is more specific. Therefore, let's not ask so many things at one time. Next big mistake is providing vague prompts. For example, a weak prompt can be like tell me about space. So it is a vague topic. Let's go and write this in ChatGPT and see what happens. Tell me about space. See, we get this. Oh my god, there are pictures also nice. Here are the basics and what's out there: stars, planet, moon, and black holes, humans in space. Therefore, for this condition, in order to fix it, we can write like give a brief history of space mentioning key milestones like Apollo 11. Let's go and write this in ChatGPT and see its response. Give a brief history of a space mentioning key milestones like Apollo 11. Oh, okay. So this is providing us the milestones like early idea, space age, moon, about working in space, and so this much. Therefore, it is better to avoid vague prompts. Another mistake can be like ignoring the iteration. Weak prompt can be like accepting a bad quality response and not refining the prompt. So in order to fix this, we have to refine and correct, also rephrase and experiment with better prompts. Applications of prompt engineering. It can be used in coding, such as writing, debugging, and explaining code. It can be applied in education field, such as in creating quizzes, study guides, lesson plans, and research. It can definitely be used in content creation for generating blog posts, script, product descriptions, and so on. It is used in customer support for automating FAQ responses. It can be used in healthcare for basic healthcare tips, diet plans, preparing patients' medical history, and so on. Hence, these are some of the applications of prompt engineering. Okay, this is all for prompt engineering. We understand that we should be more clear and specific while prompting. We can easily define format and constraints to structure our prompt. Similarly, we can improve results by rephrasing and adding more details. I hope you will use these techniques for better prompting and see the difference. In this video, we are going to learn about tokenization and know how large language model or LLM read languages. So let's start. Introduction. Large language models or LLMs such as ChatGPT, Llama, GPT-4, they do not understand the word or the text as the human does. LLMs process human language with some tokens. Therefore, in this video, we are going to understand what tokens are and the process of tokenization. What are tokens? Human language, it consists of words, grammars, punctuations, and its meaning. However, the neural networks operate only on numerical vectors. Hence, before training, the text must be converted into numerical units called the tokens. Therefore, a token is the fundamental unit of text processed by a language model. It is very important for an AI to process information. Tokens can be whole words, subwords, phrases, punctuation, spaces, characters. That is, a token is not always a word. It can be whole word, subwords, punctuation, spaces, and so on. A word may be splitted into smaller parts depending on tokenizer. For example, here is the sentence, artificial intelligence is powerful. The possible tokens for this sentence are like this. Artificial intelligence is and power and full. So the above sentence is divided into like these tokens. Here we can notice that the word powerful is divided into power and full because the model can reuse this to many other words such as useful, meaningful, helpful, and so on. What is tokenization? Tokenization is the fundamental process of converting text into smaller and standardized units called tokens. Tokens can represent words, subwords, characters depending on the tokenization method. Tokenization method transforms original sentences to numerical vectors that neural network can process. Therefore, the process of tokenization acts as a medium between machine and human language. Types of tokenization. There are three types of tokenization: word tokenization, character tokenization, subword tokenization. Word tokenization. This method splits text into individual words. This is common method and it is effective for language like English where there is a clear word boundaries. For example, the sentence AI is powerful becomes AI is powerful. Sometimes they can also be like AI is power and then next is full. So this is how word tokenization happens. Character tokenization. This method splits text into individual characters including spaces, punctuation, symbols, and letters. This is beneficial for handling typos, unknown words, spelling correction, and so on. For example, AI is tokenized like this. Subword tokenization. Modern LLMs mainly use subword tokenization. This method balances between word and character tokenization by breaking down text into smaller and meaningful units based on the pattern during training period. It helps model handle out of vocabulary OOV words. This tokenization method is popular in large language models such as GPT and BERT. For example, the word unhappiness is split into unhappy and ness. Tokenization algorithms. Some of the tokenization algorithms used in LLMs are byte pair encoding (BPE), word pace, sentence pace. Let's see tokenization example in LLM workflow. In fact, LLM, they do not generate sentences at once. They repeatedly predict the next token and build the responses step by step. The pipeline is, first, the text is converted into standardized text, such as converting sentences to lowercase or removing punctuations and so on. Then the process of tokenization occurs. After that, all the splitted tokens are represented by token IDs. Then embedding happens. It is then transferred to a transformer model. At last, the process goes for the next token prediction. So this is the overall pipeline of the LLM workflow. Why token matters in LLM? Token does matters in LLM because it affects performance, model memory, computation cost. In LLM, every prediction happens token by token. Hence, the cost and the generation speed directly depend upon the number of the tokens used. There are different challenges in tokenization. Some of them are handling emojis, symbols and special characters, multilingual tokenization complexity, token fragmentation, language dependency, handling out of vocabulary words or OOV, efficiency and computational cost. Use cases of tokenization. Tokenization is critical in numerous applications including machine translation, speech recognition, search engines, information retrieval. Okay, this is all for tokenization. We understand that tokens are unit of text. Tokenization is the process of splitting text into small tokens. Then these tokens are represented by different index numbers and they are converted into numerical vectors that LLM understands. Then LLM predicts next token. Therefore, tokenization is the process that converts human language into machine representation, which enables LLMs to generate text more effectively. In recent years, the transformer models have revolutionized artificial intelligence. The advanced systems such as GPT-4 and BERT are built by using the transformer model. Today we are learning what transformers are and how they work. So let's dive in. Transformer is an architecture behind modern AI system. In 2017, Google published a paper titled "Attention is All You Need." It did not just improve translation, it led to a new era of ChatGPT, Cloud, Midjourney, and now so many other AI systems. Today we are going to know more about transformers. Older models. The older models before transformers are recurrent neural networks (RNN), long short-term memory (LSTM). The sequence modeling on these models relied on recurrent architectures. These models process text sequentially, which means each word was processed one at a time. Hence, this creates problems such as slow training period as well as the difficulty in capturing long-range dependencies in sentences. However, transformers process the entire sentence simultaneously, which is called parallelization. Key idea behind transformers. A transformer is a deep learning architecture that processes sequences using self-attention mechanisms instead of recurrence or convolution. As I mentioned earlier, unlike RNN, instead of reading text sequentially, transformers analyze the whole sequence simultaneously, and they use a mechanism called attention. that allows the model to determine which words in a sentence are most relevant to each other. Why transformers are powerful? They are powerful because they have features such as parallel processing of sequences, ability to model long-range dependencies, highly scalable for large datasets, better understanding of context. Therefore, these kind of features of transformers enable the creation of extremely large models trained on massive data. Transformers workflow. The complete technical pipeline of transformer is: the first is input text and the second is tokenization. Here it breaks the words into numbers. And the third is token embeddings plus positional encoding. Here it adds meaning and the position. The fourth is self-attention layer. This layer, it finds the relationships between the words. And the fifth is add and norms. This is the important step because it acts like a highway that allows the original signal to pass through without getting distorted by different factors of the attention layer. Feed-forward network. Here, the processor looks at each word's new context and refines it. The next one is add and norms. It stabilizes the data before it moves to the next layer. This is also the important step. Next we have is linear and softmax. This is the crucial steps. The feed-forward network outputs raw numbers. The linear layer maps those numbers to the vocabulary, and softmax turns them into percentage. For example, there is a 95% chance next word is computer. And final is the output prediction. So this is the basic workflow of the transformer. In the original paper, Attention is All You Need, the transformer architecture consists of two components. One is encoder and the another is decoder. Encoder, it processes the input sequences, whereas the decoder generates the output sequence. Self-attention mechanism. Self-attention allows the model to determine how much attention each word should pay to the other words in the sentence. This is done using a scaled dot product attention approach. For example, here we have sentence: the lion watched the gazelle closely because it was hungry. Here, what does it refer to? The self-attention helps the model understand that it refers to the lion in this case. Therefore, self-attention allows the model to capture the contextual meaning even when words are far apart in the sentence. In self-attention, each word in a sentence is mapped to three vectors: query, key, value. Now let's see the purpose of these. The query, it provides what we are looking for. The key is for what information each token provides. The value is the actual representation of the token. Attention scores are computed as this formula. We take the query of one word and dot product it with the keys of all other words, and this gives a score. Then we normalize the scores. After that, we multiply them by the values to get the final output for that word. This is how attention score is calculated, and hence this attention score will find out how much attention each word should give to others. Multi-head attention. Multi-head attention allows the model to focus on multiple things simultaneously instead of computing attention once. For example, one head might focus on grammar, whereas another head may focus on the relationship between the nouns, and again the another head on the emotional note. In this way, this improves the model's ability to understand even the complex language patterns. Feed-forward layer. After attention, the output passes through a feed-forward neural network to process the features further like this: attention output, linear layer, activation, and then linear layer. This component allows the model to learn non-linear transformation of the attention output and refine the token representations. Encoder versus decoder. The encoder reads the input text and understands the context of it, whereas the decoder inputs the context and generates the output text. Positional encoding. Transformers do not inherently understand the sequence order as they process data in parallel. Therefore, we add positional encoding to solve this problem. Positional encoding adds information about the position of each token in the sequence. Hence, the model knows the difference between the sentences such as dog bites man or man bites dog. Transformers changed AI. It is obvious that Transformer is the foundation of modern Gen AI system because they scale very well with the data. Today, Transformers enabled us with large language models, machine translation, text summarization, AI coding assistants, chatbots, and many more. Okay, now we are at the last part of our video. So let me summarize this. We understand that the Transformer replaced RNN-based NLP model. The parallel computation allows massive scalability. Transformers change artificial intelligence by enabling models to learn contextual relationships in language through attention mechanisms. Therefore, we understand that Transformers are the foundation of modern LLMs. In this video, we are discussing one of the most important breakthroughs in generative AI, that is RAG, or Retrieval Augmented Generation. If LLMs are the engine of AI, RAG is the fuel that combines information retrieval and text generation, which makes AI more accurate. So without further ado, let's dive into our video. So what is RAG? RAG is a method which combines two components of an AI that are information retrieval, generative language models. In simple terms, the process looks first the user questions. After that, there is retrieve relevant information. Next is provide retrieved context to LLM. And lastly, generate the accurate responses. Therefore, as the model uses the real information during the generation, the response becomes more reliable and accurate. How it got named RAG? The name Retrieval Augmented Generation comes from two core steps involved in the process. Retrieval refers to searching a database source to find information that is relevant to the user's prompt. Augmented means enhancing the input prompt with retrieved information. And generation, it refers to the creating the final response. Hence, the model not only generates answers, but it also generates responses that are augmented with retrieved information. History of RAG. In 2020, researchers from Meta introduced the concept of RAG. Before RAG, AI systems mainly relied on two methods. The first is large pre-trained language models. These models generated text depending on the training data. The next is information retrieval systems. These systems searched documents but did not generate natural language responses. Therefore, RAG combines the strength of both methods, which are the retrieval systems provide accurate information and the language model generates human-like responses. Therefore, RAG has become one of the most important architectures today. The components of RAG. A RAG system has several components: knowledge source, document chunking, embedding model, vector database, retriever, large language model or generator. So these are the components of RAG. How RAG works. The working process of RAG can be explained step by step. The first is data collection. It stores collection of documents that the system will source. This may include websites, APIs, PDFs, database, research papers, and so on. Next is document chunking. Here, the large documents are divided into smaller and manageable pieces called chunks. It helps the system to process huge documents more efficiently. For example, the research paper is divided into paragraphs, then text chunks. The third step is embedding generation. In embedding, each text chunk is converted to a vector representation that captures the semantic meaning. Fourth step is vector storage. The embeddings are stored in a vector database, which allows fast similarity search. The step 5 is user query. When a user asks a question, the query is converted into an embedding. Step 6 is similarity search. The system compares the query embedding with the stored embeddings and retrieves the most relevant document chunks. The step 7 is context augmentation. The retrieved documents are added to the prompt that is sent to the language model. Step 8 is response generation. Finally, the retrieved documents are sent to the language model such as GPT-4 or Llama. The model then generates the final response using this retrieved information. What problem does RAG solve? RAG solves some of the key problems such as hallucination. Sometimes language models generate false information which looks like it is correct. RAG reduces hallucination as the model generates answers using the real data. Outdated information. Generally, language models cannot easily update their information after the training process. However, RAG allows the systems to use latest information without retraining the model. Data privacy. We cannot put our organization's secret documents into the public GPT training set. However, we can put it in a private RAG system. Hence, the RAG enables the models to answer questions based on the private company data. So these are some of the problems RAG solves. Applications of RAG. RAG is widely used in so many areas such as customer support system, research assistance, enterprise knowledge assistance, healthcare systems, legal document analysis. So these are some of the applications of RAG. So now let's summarize this video. RAG allows AI systems to generate responses that are more accurate and reliable by combining information retrieval with generative language models. This architecture helps overcome many limitations of traditional language models such as hallucinations, outdated information, and data privacy. As AI continues to evolve, RAG will play a very important role in building smart, trustworthy, and knowledge-driven AI applications. In this video, we are learning about hallucinations in LLM. Now, let's start the video. Introduction. The LLMs such as ChatGPT, Gemini, and other AI systems are very powerful. They are able to answer users' query, write code, summarize documents, and many other tasks. However, there is one big problem. The LLMs sometimes generate false information, but they sound so correct. This problem is called hallucination. Hallucinations in LLMs. It is the generation of the false, misleading, or completely fabricated information which appears confident and realistic. In simple words, we can say like this. First, the model doesn't know the user's answer. Secondly, it still generates response to user. And thirdly, the response sounds so correct, but in fact it is totally wrong. Therefore, hallucination occurs if an AI produces an answer which is factually incorrect but presented with pure confidence. Types of hallucinations. Hallucinations can be categorized into various types. The first, factual inaccuracies. This type of hallucination occurs when LLM produce incorrect or misleading facts. For example, the capital of Japan is Kyoto, which is incorrect because it is Tokyo. The second type is nonsensical responses. This type of hallucination occurs when LLM generate completely irrelevant responses to the user's input prompt. The response may lack meaningful content. The third is contextual hallucinations. This occurs when the model misunderstands the context and produces completely wrong answers. Next, logical hallucination. This type of hallucination happens when the reasoning is incorrect, even if the sentence looks logical. For example, if the question is like, can human breathe underwater without any equipment? Then the model's answer is, yes, human can adapt to breathe underwater for short durations. So this is incorrect because humans cannot breathe underwater without equipment. Here, the model generates a plausible but false statement. Causes of hallucinations. Hallucinations is not a minor problem. It can create major issues. LLM hallucinations can be caused due to various factors. These are noisy training data. If the quality of the data to train LLMs is not good or noisy, then the model does not perform accurately. Nuanced language understanding. LLMs may find difficulties in understanding the different language contexts such as cultural nuances, sarcasm, and likewise. Complex queries. If the user's prompt is very complex, the model might not respond correctly. Overfitting and underfitting. As we know that overfitting the training data can lead the model more specific, whereas underfitting can often generalize the response. Therefore, both of these methods can lead to hallucinations. Logical gaps. If the model lacks common sense or any logical reasoning on the user's question, then this can lead to hallucinations. Inherent biases. If the model inherits biases in the training data, this can also lead to hallucinations. Hence, these are some of the causes of hallucinations that we should be careful about. Preventing hallucinations. There are different methods to reduce hallucination. Some of them are using high quality training data. If the training data is more verified and accurate, then there is less probability of hallucinations. Better prompting. We can provide better prompts. For example, if we are unsure about certain topic, then we can say, I don't know about this, please check the fact correctly. Hence, this can reduce false confident answers. Output filtering. We can implement filtering for hallucinated outputs by using factual check. Feedback mechanism. We can establish user feedback system by using techniques such as reinforcement learning, so it can continuously refine and retrain the models. Fine-tuning. Models can be continuously trained and updated with recent high quality and accurate data. Domain-specific training. We can train the model according to the specific domain such as healthcare, law, and aid experts' idea during the fine-tuning process. Therefore, it can reduce hallucination in such topics. Okay, these are some of the methods to prevent from hallucinations. However, it cannot be completely removed. Therefore, it is essential to be more cautious while using LLMs for important tasks. Implications of LLM hallucinations. Misinformation. If an LLM produces a hallucinated answer, sometimes users may believe it. Hence, it can contribute to the spread of misinformation. Trust issues. If LLMs give wrong answers confidently, user may lose trust. Legal and ethical concerns. There can be legal and ethical concerns such as who is responsible for the output generated by LLMs and so many other factors. Risk in critical domains. In the fields like healthcare, finance, law, hallucinations can lead to serious consequences. These are some of the implications of LLM hallucinations that we should be aware of. Okay, this is all for the topic hallucination. We came to know that hallucination is one of the biggest challenges in modern AI systems. Although the recent LLM systems are highly advanced, they can still generate misleading information or incorrect facts. Therefore, we should have basic knowledge of hallucination as it helps us to use AI more responsibly. Today I am here with the topic fine-tuning. In this video, we'll learn what is fine-tuning, why it's important, and why we should actually use it. So without further ado, let's start our video. What is fine-tuning? Fine-tuning is the process of taking pre-trained AI model and training it again using a smaller task-specific dataset to improve its performance. Let's think like this. General AI model is with general knowledge, which can be a model trained on the internet. Whereas fine-tuned model is a specialization for particular domains such as healthcare, finance, or customer service. For example, a general AI model knows English very well, and after fine-tuning the model, it becomes a medical expert. Therefore, instead of building a new model, we adopt an existing one. Why fine-tuning? The problems of models without fine-tuning are: they give generic responses. The pre-trained model may have wide knowledge, but they often lack deep understanding in specific domains. They may sometimes create hallucinations. The problem without fine-tuning may sometimes generate hallucinations as the model may produce misleading information, inconsistent tone or style. The responses of the model may vary in tone or style, which can sometimes make unsuitable. Lack of domain expertise. The model without fine-tuning might not provide correct answers when responding to specialized topics. Hence, fine-tuning helps improve accuracy in a specific domain, control output style, make responses more consistent, reduce unwanted behavior. Types of fine-tuning. Supervised fine-tuning. Here, the model is trained on label data with input-output pairs. Instruction fine-tuning. Here, the model is specially trained to follow certain instructions such as summarize this, translate that. Full fine-tuning. In this method, all the parameters of the model are updated, which gives high accuracy but requires more resources, and it is time-consuming. Feature-based fine-tuning. Here, the model is used as a feature extractor and only additional layers are trained. Parameter efficient fine-tuning. Here, only a subset of parameters is updated, which makes the process faster and cheaper. Some of the examples are LoRa, low rank adaptation. LoRa reduces computational cost by updating only low rank matrices within the model. Next, adapters. Small modules are added to the model to enable learning without modifying the entire network. How fine-tuning works. Start with pre-trained model. The first process begins with a model which has been already trained on the huge datasets. Next, prepare a specific dataset. The next step is to gather high-quality specific dataset that is required to perform our target task. High-quality data is equal to better fine-tuning. Training the model. The next process is to train the model on new data. The model learns patterns from this new dataset through additional training. Update weights. The internal parameters of the model adjust its internal weights in order to better match our new data. Get updated model. After training process, our fine-tuned model performs better. That is more accurate on the specific task and we get better response on our targeted style. Benefits of fine-tuning. Higher accuracy in a specific task. Fine-tuning improves the performance in specific fields such as medical, legal, technical domains, and so on. Better control over tone and style alignment. It allows the developer to define how an AI model communicates, such as speaking just like a specific persona. Consistent responses. The model produces stable outputs. Reduces hallucinations. Fine-tuning helps minimizing incorrect or fabricated responses. Challenges of fine-tuning. Data quality problems. Poor quality data can negatively impact the model performance. Risk of overfitting. The model may memorize the whole training data instead of generalizing. In that scenario, the model cannot handle new variations. Can be expensive. Training requires significant computational resources, cost, and time as well. Difficult to update frequently. Updating the model needs retraining the model with new data. Fine-tuning use cases. Medical AI systems. These AI models can assist doctors by understanding medical terminologies. Customer support chatbots. Fine-tuned AI bots can provide accurate responses to customer queries of a specific company. Code generation. Fine-tuned AI model may help developers by generating code more accurately. Content generation. AI can create content according to each content creator's preferences. Legal document analysis. Fine-tuned AI models can identify complex legal documents easily. When to use fine-tuning? We can use fine-tuning when we need consistent output style. Fine-tuning is useful when we need to maintain a specific communication style or format of the response. Prompting is not enough. Fine-tuning is important if simple prompting fails to produce desired responses. We use fine-tuning when we have domain-specific data. It works best when the task needs deep understanding of a specific domain and if we have access to high-quality datasets. Future of fine-tuning. Continuous learning. Fine-tuning models can update themselves continuously as they receive new feedback and make the model's performance better. Efficient training. Advances in the hardware and algorithms may reduce cost, hence it can be more cheaper and faster to train the models. Personalized AI models. Fine-tuning AI models may become more tailored to individual users. Agentic alignment. Fine-tuning models able to use external tools such as APIs, browsers autonomously. Summary. Okay, this is all for fine-tuning. We understand that fine-tuning is all about making AI more smarter as it transforms a general purpose AI model into a specialized AI model. Refine an existing model. Instead of creating a new AI model, fine-tuning is all about refining an existing model into domain-specific experts, essential for real-world application. Fine-tuning is one of the key techniques which is very essential in this modern AI world. Today we are learning Model Context Protocol, that is MCP. So let's start our video. Model Context Protocol. Let's imagine we are using a powerful AI model which can answer our complicated prompts. But if we ask, can you check my recent emails and summarize them? Then AI replies as, I don't have any access to your emails. In this scenario, we feel AI are limited. Hence, in order to connect AI to real data, tools or systems, the role of Model Context Protocol or MCP comes in. Now let's understand what actually is MCP. What is MCP? MCP is introduced by Anthropic in November 2024. Model Context Protocol or MCP is an open source standard for AI models such as chatbots, agents or IDE assistants to interact with external services such as data sources, tools and applications. Hence, in simple terms, we can say MCP acts as an universal connector which allows AI models to connect with the outside world. The problem MCP solves. Now, let's clearly understand the situations without MCP first. Therefore, without MCP, it relies only on the training data. It only responds based on the prompts. AI cannot access external system. It cannot interact with tools and perform appropriate tasks. For example, if we ask, analyze our company's profit margin of this month, a normal AI model cannot perform this because it does not have access to our company's internal data. But with the use of MCP, AI connects to our database. AI can read actual files. It can query databases. And it can analyze it. And it also can call APIs. So MCP solved these problems and it transformed passive AI to an active AI model. For example, agents can get access to our personal calendars and can act as a personal AI assistants. Components of MCP. The MCP components work together to help LLMs and external systems to interact easily. MCP host. The MCP hosts are the applications such as cloud desktop or IDEs the user interacts with. MCP client. MCP client is the interface within the MCP host which helps LLM communicate with the MCP servers. MCP server. MCP server is the external service that provides specific data, context, tools and resources. It handles communications, requests and manages tool interactions. In this way, all these components create a complete system for the smart AI interaction. MCP versus RAG versus fine-tuning. Let's understand the difference between these three terms. MCP. It focuses on the tool interactions. The purpose of MCP is to enable different actions, real-time access, and provide capabilities. RAG. RAG focuses on the information retrieval. The purpose of RAG is to provide relevant documents and provide knowledge. Fine-tuning. Fine-tuning focuses on model training. The purpose of fine-tuning is to improve behavior, accuracy, and intelligence. Hence, these are the differences between MCP, RAG, and fine-tuning. Use cases of MCP. MCP enables smart applications such as AI assistant accessing personal documents, building advanced integration systems, AI agents interacting with multiple tools, real-time analytics tool, smart coding assistants, and many other AI models. Challenges of MCP. MCP has different challenges such as privacy and security risk. AI accessing private and sensitive data must be controlled. Tool calls may slow down the responses. Reliability issues. As it has to connect with external systems, sometimes it may fail. Therefore, it may have the reliability issues. Okay, this is all for MCP. We understand that MCP connects AI with external tools and data. It enables real-time interaction. MCP solves the integration bottleneck. Hence, MCP is not just a tool, it is the foundation for autonomous AI systems. By standardizing the interface, we use the full potential of LLMs to interact with the real world. Today we are learning about multimodal AI. Now let's dive in. What is multimodal AI? Imagine an AI system that can look at an image, read text, listen to audio, and then respond intelligently across multiple types of data. This is the main idea of multimodal AI. In the past, AI systems are unimodal. That is, one model translated text, whereas another model identified object in the photos or videos. However, the real world is not unimodal. We humans inherently have multiple intelligence. For example, when we sit in a room watching television, we can sense different other factors like sound of train outside, cat walking into the room, and so on. Multimodal AI seeks to replicate this sensory integration. Therefore, multimodal AI refers to a system that can process, understand, and generate multiple types of data simultaneously, such as text, images, audio, video within single unified framework. For example, multimodal AI system performs looking at an image and generating a caption, listening to the speech and converting it into the text. Now let's compare both of these models. Unimodal AI versus multimodal AI. Unimodal AI, it works with only one type of data. Multimodal AI, it works with multiple data types together. The examples of unimodal AI are text-based chatbots which only process text and image classifier which only process images. Whereas the multimodal AI combines information across modalities. Unimodal AI, these systems are effective within their domain only. They lack the ability to integrate information across different models. Now let's see an example. A unimodal system might classify an image as a dog, whereas a multimodal system can answer what is the dog doing and why. Therefore, multimodal AI uses multiple signals simultaneously just like the humans do. In this way, multimodal systems are more closer to human intelligence. Generative AI versus multimodal AI. These two terms are often confused, but they are not the same. Generative AI, it focuses on creating new data. The examples are generating text, images, code. The multimodal AI, it focuses on processing different data types. Therefore, a system can be generative but not multimodal. It can be multimodal but not generative, or it can be both. Today's advanced AI system, they are both generative and multimodal. Now let's see how multimodal works. It typically works in 4 stages. Step 1, data preprocessing. Data from multiple formats is gathered and preprocessed, such as tokenizing, resizing images, and so on. The step 2 is feature encoding. Each type of data is converted into machine-readable numerical representation. Text is converted into vector representations, images are converted into feature maps, audio is converted into frequency features. This step ensures that different data type can be processed mathematically. The step 3 is fusion mechanism. Once encoded, the next step is to combine these representations. This is called the fusion. The system learns relationships such as text describing an image, audio matching a video. Step 4 is reasoning and output. After the fusion, the model performs reasoning over the combined data. It identifies patterns, relationships, and context and then generates a proper response. The output can be text, image, audio, or a combination. The important thing here is the model is not just processing inputs, but it is also reasoning across different modalities. Popular multimodal AI. Here are some widely known multimodal systems. GPT-4, it handles text, images, and audio. Cloud, it has strong reasoning with multimodal capabilities. Gemini, it is designed for multimodal reasoning. Clip, it connects images and text. DALL-E, it generates images from text. So these are some of the popular multimodal AI systems. Benefits of multimodal AI. Multimodal AI offers several advantages. Better understanding of context. With combining multiple sources of information, the system can interpret meaning more accurately. Improved accuracy. It reduces ambiguity by using multiple inputs. More natural interaction. It enables human-like communication. Versatility. It works across different types of tasks. Enhanced user experience. It provides richer and more meaningful outputs. Multimodal AI has different practical applications across various industries. For example, healthcare. In healthcare, it can combine medical images with patient records to assist diagnosis. Customer support. AI models can analyze voice messages, images, and text simultaneously. Content creation. In content creation, multimodal AI can generate text, images, videos together. E-commerce. Users can source products using images and text. Autonomous vehicles. In autonomous vehicles, the systems combine camera input, sensor data, and maps to make decisions for choosing better route. Multimodal AI risk. Misinterpretation across modalities. They may misinterpret relationships between modalities, leading to incorrect conclusions. Privacy concerns. There may be privacy concerns, especially when processing images, videos, and audios. Deepfake generation. They can be misused to create deepfakes or misleading content. Bias amplification. There may be bias in multiple data types. Challenges of multimodal AI. High computational cost. It requires large models and resources. That's why it is expensive. Complexity in training. Lack of standardized dataset. There is limited high-quality multimodal data. Future of multimodal AI. Autonomous systems such as self-driving cars, robots, and so on. More natural AI systems. Advanced human-computer interaction. Advanced AI assistants that can understand voice, vision, and text together. Summary. Multimodal AI systems represent a significant advancement in artificial intelligence. It enables systems to process multiple types of data, understand relationships across modalities, interact more naturally with humans. Hence, multimodal system is very important to build advanced real-world AI systems. Today's video is all about mixer of experts or MOE. Now, let's get started. What is mixer of experts or MOE? Mixer of experts is a neural network architecture where smaller specialized sub-networks called experts work together and decide which experts should be used for a given input. In traditional model, every single parameter or every neuron fires for every word we type. Therefore, the model becomes large, inefficient, and costly. Hence, instead of using the entire model for every task, MOE distributes knowledge across multiple experts because not all the parameters are used for every input. Why do we need MOE? Modern AI systems require massive capacity, that is billions and trillions of parameters. Therefore, it has high computational cost. Hence, if we use the entire model every time, it becomes very inefficient. MOE introduces a key innovation, that is, only a small subset of experts is activated per unit, and the rest of the model remains inactive. Now, let's see how MOE works. The input, for example, an image, is first converted into numerical representation. The step 2 is gating network or routing mechanism. The gating network performs dynamic routing. Its job is to analyze the input, assign scores to each expert, and it acts like a decision maker. Step 3 is top K selection. Instead of selecting all the experts, the model selects only the top K experts based on the highest scores. For example, if K equals to 2, only the top 2 experts are activated. This is called sparse activation. The step 4 is expert processing. Each selected expert processes the input independently. The experts are the neural networks specialized in different patterns. Each expert produces an output vector. The step 5 is output combination. The outputs from selected experts are combined to produce the final result. Therefore, this is how MOE works. Benefits of mixer of experts. Massive scalability. It can increase parameters without increasing the cost. Improved performance. It has better handling of the complex task. Efficient computation, because only a few experts are active. Specialization. Experts can focus on a specific language or reasoning task. Challenges of MOE. There is complexity in the training because it is harder to train than the dense model. There may be routing errors if gate network may choose the wrong experts. It is difficult to fine-tune MOE models without losing their specialized balance. Communication overhead. Data movement between experts can be expensive. Use cases of MOE. MOE is used in advanced AI systems for large language models, machine translation, recommendation systems. Different AI models use MOE to handle large workload efficiently. Future of MOE. The future of MOE is very promising. It is more adaptive and dynamic systems. There will be integration with multimodal AI systems. The larger models with efficient computations can be developed. Hence, MOE is a key method to scale artificial intelligence. Now, let's summarize Mixer of Experts or MOE. We understand that MOE uses multiple specialized experts, and only a few experts are activated according to the given input. Hence, this concept makes AI more reliable and efficient. In this way, we can say MOE is the bridge to artificial general intelligence. Today, we are diving into something that's completely changing how people build software in 2026, that is vibe coding. In this video, I will explain exactly what is vibe coding. So without further ado, let's start our video. So what exactly is vibe coding? Vibe coding is a new approach to a software development where the programmer's job shifts from writing the code manually to start vibing with AI using user experience, intent, and high-level instructions. For example, instead of thinking, how do I write this program? We can think like, what do we want for the system to perform? And then in that case, first AI generates the code, then we can refine and debug it according to our requirements. So it is easy to iterate quickly. If the code works, then the vibe is correct. Hence, we can say vibe coding equals to programming by intent, not by syntax. Therefore, vibe coding is less about coding and more about shaping the response of our prompts. Is vibe coding a new concept? We know that low-code tools have been existed for years. But the vibe coding is different because it is not limited only on the drag and drop interface. It uses the power of LLMs or large language models. Therefore, AI tools built on them are very good at understanding context and the intent of the prompts. Hence, today we can build almost anything such as games, mobile apps, web apps, extensions, and so on. Traditional development versus vibe coding. Now, let's see the difference between vibe coding and traditional development. In traditional development setting, we write the code line by line, such as in Python, C++, Java, and so on. Whereas in vibe coding, we use natural languages such as English to describe the prompts. Earlier, we used to have documentation and libraries for knowledge base in traditional development setting. Whereas in vibe coding, we have AI training data and its context. Traditional development, it has a strong focus on syntax and structures. Whereas in vibe coding, AI generates the code. In traditional setting, developer controls everything. Whereas in vibe coding, developer just acts as an editor. In traditional development, there is slow iteration. Whereas in vibe coding, there is rapid iteration and experimentation. Therefore, these are some of the key differences between vibe coding and traditional approach. How to implement vibe coding? Now, let's discuss the workflow for vibe coding. First is define the vibe clearly. That means we can start with a high-level description such as what the system should do, its input and outputs, and what is the context, and so on. Basically, we have to define the intent more clearly. Next is iterative prompting, that is, run the code. If there is a mistake, refine your prompts and improve your results step by step. The last step is verification and optimization. First, check the correctness of the output and then optimize the performance of it. Finally, ensure the security of the task we performed. Hence, this is the general implementation of vibe coding, which is like coding with AI in collaboration. Now let's talk about some of the popular vibe coding tools. The first is ChatGPT. It generates and explains code nicely. Another is Cloud. It is very good at complex projects. Next is Cursor. It is an advanced AI-assisted code editor. Next is GitHub Copilot. This suggests code in real time. Another is Replit, which is an AI-powered development environment. It allows to build and deploy entire apps from a single text prompt. Okay, these are some of the vibe coding tools. There are different others too. Now let's discuss what are the actual benefits of vibe coding. One is faster development. It is possible to build applications in hours. Next is creativity. One can focus on what to build rather than how to write the code, so it motivates for the experimentation. Another is lower cognitive load. Beginners can start coding easily. There is no need to memorize the syntax. Last is it increases productivity. With the vibe coding, developers can focus on logic, not the syntax. Hence, it will definitely increase the productivity. So these are some of the benefits of vibe coding. Downsides of vibe coding. There is a lack of deep understanding. Developers may lose fundamental knowledge and may not fully understand generated logic because they heavily rely on AI. There may be hallucination. The AI might use non-existent libraries and create problems. These are some of the downsides of vibe coding which we should be careful about. Now let's discuss the use cases of vibe coding. First is startup development. With the vibe coding, we can build the product faster with small teams. Next is learning programming. We can understand the basic concepts of programming with AI's help. We do not need to look for the programmers to teach us. Rapid prototyping. That means we can quickly build idea to a basic demo. Startup development. We can build products more faster with even smaller teams. Automating repetitive tasks. We can easily generate scripts for automating repeating tasks. Building internal tools. We can build the custom dashboards or utilities for the team. So these are some of the use cases of the vibe coding. Okay, this much for vibe coding. We understand that vibe coding focuses on intent-driven development. It increases speed, creativity, and accessibility. With vibe coding, AI assists in writing and improving the code. Although we have many benefits for vibe coding, it requires careful validation and oversight also. Now that's all for an artificial intelligence fundamentals. Next, we move to machine learning. So, what is machine learning? Machine learning, often called as ML, is a branch of an artificial intelligence that enables a system to learn autonomously from data and make decisions without being explicitly programmed to do so. The performance of machine learning model can be improved by providing large datasets and let the model figure out the patterns. Let's imagine how we teach a child to recognize a dog. We don't tell them proper rules to recognize a dog, but we show them many dogs and say this is a dog. Therefore, over time they learn how a dog looks like. So, machine learning works the same way. We train the machine by showing it with lots of examples and it learns how to make decisions based on that. Traditional programming versus machine learning. Now let's compare machine learning with traditional programming. In traditional programming, we write a set of predefined instructions and the computer follows those instructions in order to perform the task. Whereas in machine learning, we give set of examples, that is huge amount of data plus our expected outputs. And in machine learning, the computer learns the rule automatically and figure out how to accomplish the task. Therefore, machine learning is very versatile and powerful as it learns from the data and improves its performance continuously. So, why machine learning matters? As we know, there are lots of data these days and machine learning can handle this large set of data, analyze it and find a proper value as an output. Machine learning is also leading to the exciting innovations. It is the heart of many technologies we use today such as drones, VRs, robots and many more. It can contribute to business, finance, by fraud detection, detecting security threats, disease diagnosis and so on. Therefore, machine learning is at the heart of many technologies we use today. It helps machine to read like spam detection and machines to see, such as object detection, face recognition. Similarly, it helps machine to decide on fraud detection, choosing recommendations, and it also helps to hear by choosing voice assistants such as Alexa or Siri. It helps machine to create by generating images, text, videos, and so many things. Therefore, machine learning is very important as it is transforming various industries in near future. Now, let's understand the basic flow of machine learning process. The step 1 is problem statement. In order to decide which category of machine learning models we use, at first we should have a deep understanding of our problems. The next step is data collection, where we collect all the data like emails, numbers, photos, and so on that is required for our models. And the next step is data processing. This step is very important part in the machine learning. It is like cleaning the data by correcting errors, scaling, and removing duplicates and so on. The fourth step is to choose the right model. We should choose proper machine learning model for our clean data. Step 5 is to train the model. Once we decide machine learning model, the next step is to train the model. Training process is feeding the data to a learning algorithm. Once we train the model, the next step is to test the model and see how well it predicts a new and unseen data. The next step is to tune and optimize the model by using more data or better methods. The last step is deployment, where machine learning model is tested in production environment. Types of machine learning. Machine learning is divided into supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. Supervised learning models learn from the labeled data. That means we provide input plus correct output. The goal here is to predict future output. Examples are object detection, spam detection, forecasting, and so on. Next we have is supervised learning algorithms. There are different algorithms in supervised learning like linear regression, logistic regression, decision trees, support vector machines or SVM, k-nearest neighbors KNN, random forest, naive-Bayes algorithm. So we will discuss about supervised learning in our upcoming videos. Now let's move to the unsupervised learning. Unsupervised learning. Unsupervised learning models learn from on-level data. That means we only provide lots of input data and we do not give known output to the model. The goal here is to find structure in data and provide us the proper output. The examples are recommendation engines, anomaly detections, medical imaging, and so on. Next is unsupervised learning algorithms. We have hierarchical clustering, fuzzy means, k-means clustering, and so on. Reinforcement learning. In reinforcement learning, the model learns by doing and through various trials and errors. The examples are game AI like chess, robotics, self-driving cars, and so on. Now reinforcement learning is rapidly growing with huge potential and we will experience more groundbreaking innovations in near future. Applications of machine learning. Machine learning is almost everywhere now, like in self-driving cars, security, recommendation systems, customer service, voice assistance, fraud detection, digital marketing, search engines, and face recognition. Supervised learning. So let's get started. So what is supervised learning? Supervised learning is a type of machine learning where the model is trained using labeled data where each input has a corresponding correct output. Here, the labeled data means a dataset which contains lots of examples. As shown in the figure, we have animal database which contain different types of animals which are labeled and stored. And in supervised learning, the trained model learns to predict the output from the input by finding patterns or the structures in the data. Supervised learning example. This is the example of supervised machine learning algorithm. So here in input side, we have collection of raw data, that is large set of tigers, camels, horses, which are labeled according to their names. Then the algorithm is trained with this information. and the processing happens, so machine would find a way on its own to identify which one is tiger or camel or horse, and finally we'll get our expected output. So this is supervised machine learning, and it is most commonly used method. Supervised learning process. Now let's walk through a basic supervised learning workflow. First is collect data. We perform data collection such as images, text, numbers, and so on. And the next is label the data, where we add correct labeling to our data. For example, cat, dog, if we are training for that. And another is split the data. Here we split the data into training dataset and testing datasets. And next we have is choosing a model. We have to choose a model such as logistic regression or decision tree or any other that is fit for our model. And the another is to train the model. Here the model is fed with the training data, so it learns the patterns and relationships between input data and the output data. Another is evaluate the model. We evaluate the model by using our test data to see performance of our model. And finally, use it. Once we find the model is accurate, then we use it for predictions on new data. Therefore, this is the basic flow of supervised machine learning. Now let's see the types of supervised learning. Types of supervised learning. There are two tasks of supervised learning. One is classification and the another is regression. Classification. In classification, the models learn to assign labels and the output is a categorical variable. The examples are emails are classified as spam or non-spam emails. Similarly, the model can classify an image into a dog image or a cat image. Linear classifiers support vector machines, decision trees, and random forests are the common types of classification algorithms. Regression. In regression, the model learns to estimate a value. Therefore, the output is a continuous variable. For example, regression models are useful for predicting house prices, forecasting sales, estimating temperature, and so on. Linear regression, logistic regression, and polynomial regression are some of the regression algorithms. Supervised learning applications. Supervised learning is everywhere. Therefore, let's look at some of the examples. It is applicable in stock predictions, like predicting stock prices based on past data. Fraud detection. Supervised learning is used for fraud detection on banking to identify whether the transaction is legitimate transaction or not. It is also used for medical diagnosis, such as images labeled as cancerous or healthy. Another is spam detection. As I said earlier, emails can be labeled as spam or non-spam by the use of supervised learning. Next is voice assistant, such as recognizing sounds like play music or stop the music. Therefore, these are some of the practical examples of supervised machine learning. Supervised learning algorithms. Here are some commonly used algorithms in supervised learning. Decision trees. Decision tree is a type of supervised learning algorithm where flowchart like models is used for decision making. Linear regression. Linear regression is a type of supervised learning regression algorithm that is for predicting numbers. Logistic regression. Logistic regression is a supervised learning classification algorithm which is used to predict binary classification. Random forest. Random forests are made up of a group of decision trees which work together to make predictions. K-nearest neighbor, that is KNN, classifies based on the closest data points. Naive-Bayes algorithm. Naive-Bayes algorithm is a supervised learning algorithm based on Bayes' theorem. SVM or support vector machines is great for separating two classes. Hence, we use these types of supervised learning algorithms according to the dataset and the problem we are solving. And I will definitely make detailed videos on each topics in my upcoming tutorials, so keep watching my channel. In today's video, we'll break down unsupervised learning in the simplest way possible. So let's get started. What is unsupervised learning? Unsupervised learning is a type of machine learning algorithm where the model learns from the unlabeled training datasets. This algorithm discovers hidden patterns, structures, and relationships within the data without any prior knowledge of the outcomes. That means the model has only input parameter as we don't provide output parameter to our model. So the model is basically learning without supervision. Let's see an example of unsupervised machine learning algorithm. So for input, we have collection of large set of tigers, camels, horses dataset, but these data are unlabeled. Then algorithm is trained with these raw datasets. In the interpretation stage, the model figure out how to organize raw datasets based on inherent patterns and structures. Then, algorithm is all about choosing unsupervised learning algorithms such as clustering, anomaly detections, or other in order to find the patterns in the data. After that, the processing happens, where the algorithm is applied on the data and a machine would find which one is tiger, camel, or horse. Then, finally, as a result, we will get our expected output. Unsupervised learning process. Now let's discuss a basic unsupervised learning process. The first is collect data. At first, we collect raw data like text, numbers, images, and so on. Then pre-processing. We clean the raw and unlabeled data by handling missing values, removing repetitive data, normalizing, and so on. Then there is a model selection. We choose machine learning algorithms such as clustering. After that, we have model training. Here, the model is fed with the training data, so the algorithm finds the patterns or the structure in the data. And next is evaluation, where we evaluate the model to see its performance. And then finally, we use the model. Since there are no correct outputs to compare, we don't use accuracy like in supervised learning. So this is the basic flow of unsupervised machine learning. Now let's see the types of unsupervised learning. Types of unsupervised learning. There are three main types of unsupervised learning: clustering, association rule algorithm, dimensionality reduction. Now let's go and see each of them. Clustering. Clustering is grouping of unlabeled data into clusters based on their similarities or differences. The goal of clustering is to identify patterns or the structures in the data. The real-world examples are pattern recognition, image segmentation, customer segmentation, and so on. Association rule method. An association rule is a rule-based technique for discovering relationships between parameters in large dataset. They are used for market basket analysis. Market basket analysis is a data mining technique which is used for better understanding of customer purchasing patterns based on the relationship between different products. For example, the customer purchase patterns. Different shops use this algorithm to find the association among the sale of one product with respect to another product according to customers' behavior. For instance, if a customer buys shoes, then he or she may also buy socks or slippers or boots. It seems like in Amazon's term that these customers who bought this item also bought. Dimensionality reduction. Dimensionality reduction is a technique used for reducing the number of features or dimensions in a dataset while also preserving the integrity of data as much as possible. This feature is used when the number of features in dataset is large, and this process is typically used in pre-processing stage. This process is performed because visualizing data in more than 3 dimensions is very difficult. If the dimension is reduced from high to low, then it also lowers the computational load and it increases the speed and efficiency. The example is like in visualizing high dimensional data or the data compression, image recognition, and so on. Unsupervised learning applications. The applications of unsupervised learning are in recommendation systems for various products and services, customer segmentation for personalized marketing, natural language processing to categorize articles, anomaly detection in cybersecurity and finance, computer vision for object recognition, medical imaging for image detection, segmentation, and so on, climate support for weather analysis, data compression, and feature extraction in deep learning. Therefore, these are some of the applications of unsupervised learning. Now let's move to the next chapter. Unsupervised learning algorithms. Now let's see some popular algorithms used in unsupervised learning. In clustering, we have K-means clustering, hierarchical clustering, density-based clustering, spectral clustering, Gaussian mixer models. In association rule method, we have a priori algorithm, eclat algorithm, FP growth algorithm, and in dimensionality reduction, we have principal component analysis, PCA, linear discriminant analysis, LDA, factor analysis, autoencoders, and so on. So these are some of the unsupervised learning algorithms, and each algorithm has different strength depending on the dataset and the goal. In today's video, we are learning about regression. So let's get this started. So what is regression? Regression is a supervised learning technique used to predict continuous numerical values based on one or more independent features. It helps to make better decisions by finding relationships between variables. There are two types of variables in regression. One is independent variable and the another is dependent variables. For example, regression can be used to predict a stock price, house price, and so on. It helps to answer questions like what will be the value of X given Y. Types of regression. Now let's talk about the types of regression. The first is linear regression. It assumes a linear relationship between dependent and independent variables. The example is like predicting height from A's, weight from A's, and so on. The next is multiple linear regression. This is same as the linear regression but with multiple input variables. The example is like predicting the price of house based on multiple features like location, room size, and so on. The third is polynomial regression. It is used when there is non-linear relationship between variables. The example can be modeling growth curves in biology. Another is Ries and Lasso regression. These are regularized versions of linear regression. They help avoid overfitting by adding penalties to the model. Support vector regression (SVR). SVR has same concept as support vector machines, but it is for predicting continuous values, and it tries to fit the best line within a margin of error, and it is good for high-dimensional data. Decision tree regression. It uses a tree-like structures to make decisions. Random forest regression. It is an ensemble method which builds multiple decision trees and averages their predictions. It reduces overfitting and increases accuracy. Regression evaluation metrics. Here are some of the evaluation metrics for regression. Mean squared error (MSE). It is the squared difference between actual values and the predicted values. Root mean square error (RMSE). It is the square root of mean squared error. Mean absolute error (MAE). It calculates the average absolute difference between predicted and the actual values. R squared core coefficient of determination. It measures how much of the variance in the target variable is explained by the model. Higher values is better fit, ranging from 0 to 1. Regression workflow. Here's how a regression model works. The first is collect the data. Here we gather data, that is independent variables and dependent variables. The second is pre-process the data. We handle the missing values, normalize and split into train and the test datasets. And the third is train the model. We use an algorithm like linear regression to learn patterns in the training data. The fourth is make prediction. The model predicts new outputs based on unseen inputs. The last is evaluate the model. We evaluate the model to measure how accurate the predictions are. So this is the workflow of regression. The real-world applications of regression are in finance, such as predicting stock prices, interest rates, and so on. In energy, such as forecasting electricity demand. In business, such as inventory planning, sales and revenue forecasting. In healthcare, such as predicting patient result or recovery time. In agriculture, such as estimating crop production. Advantages. Let's see the advantages of regression so it will be easier to understand when to use it. The first is it is easy to understand and implement, so it is great for beginners. Fast and efficient. It is fast and efficient because regression models can train fast even on huge datasets. It works well for linearly related data. Disadvantages. Sensitive to outliers. They can be sensitive to outliers. Can underfit complex data. Simple regression models may miss patterns in complex datasets. That's why it can lead to low accuracy. Need attention in pre-processing. There needs an attention in pre-processing because regression is affected by missing values, non-normal data, and so on. Today we are going to learn about linear regression. So without further ado, let's start our video. So what is linear regression? Linear regression is a type of supervised machine learning algorithm where the model learns from the labeled data and identify patterns from those data to make predictions. and there is a linear relationship between input and output, which means if we give some input data, then it will try to predict an output number, such as in predicting the price of house. And it's like drawing a straight line through our data and finding the best possible relationship between the inputs and the outputs. Let's see an example. Suppose we are trying to predict a student's score based on number of hours they have studied. It is obvious that if a student study for more hours, then they will get better marks. Let me explain this. For example, I have some data like this. Here we have two variables. One is independent variable x, which is study hours, and the another is dependent variable y, that is score. So let's assume if the student study for 1 hour, they will score 54, and if they study for 2 hours, they will score 60, and if they study for 3 hours, they will score 66, and 4 hours they will get 71, and if they study for 5 hours, they will get 79. So this is our data set, and if we plot this in graph, we will see like this. So see, here we get a straight line, and the score changes at a constant rate as the input changes. That is, if students study for more hours, then they will get more score. Hence, this is what simple linear regression looks like. Linear regression applications. It is often used in predicting house prices. For example, linear regression helps us to create a model to predict the price of the house based on its size. Bigger the house, higher the prices. It is used in education to predict student performances. In finance, to predict stock prices. In marketing, for example, a company wants to know how much to spend on ads to increase sales. In that case, linear regression helps them to forecast sales for given ad spends. It can be used in agriculture. For example, farmers can use data such as temperature and rainfall to predict crop yields and so on. Therefore, these are some of the applications of linear regression, as we are dealing with numeric and continuous values, which is exactly what linear regression is designed for. Mathematical expression. Mathematical expression, or the best fit line for linear regression with one independent variable, is given by y equals to mx plus b, where x is the input, that is independent variable, y is the predicted value, that is dependent variable, m is the slope of the line, that is how steep or how much y changes for a unit change in x, and b is the intercept, that is when line cuts y-axis, or the value of the y when x equals to 0. The goal of linear regression is to find the best values for m and b that fit our data. Let's see the real example and calculate slope m and intercept b. So I am going to take the earlier data set. We have study hours as x, a dependent variable, and the another is scores, that is y, which is independent variable. Now let's calculate the mean of x. As shown in the table, we add all the values of x and divide by 5. Then we will get the mean of x. That is 1 plus 2 plus 3 plus 4 plus 5, and then divide by 5, and the result we get is 3. So this is our mean, and we represent it as a x dash. Similarly, we calculate mean of y, and as shown in the table, we get the value 66. Next step is to calculate the deviation of x, that is x dash, which is our mean value, minus x. Suppose 3 minus 1 equals to 2, 3 minus 2 equals to 1, and so on. Then we calculate the square of deviation of x, that is square of 2 is 4, 1 is 1, 0 is 0, minus 1 is 1, minus 2 is 4. And next step is to calculate deviation of y, that is y dash minus y. Then we calculate x dash minus x into y dash minus y, and as a result we get like 2 into 12, that is 24, 1 into 6, that is 6, and so on. And at last we calculate the sum of product of deviations, that is 24 plus 6 plus 0 plus 5 plus 26, that is equal to 61. So these are our calculations. The formula to calculate slope is m equals to sum of product of deviations divided by sum of square of deviations of x. That is 61 divided by 10 equals to 6.1. So this means if I change the value of x by 1 unit, then the value of y changes to 6.1. And the formula to calculate intercept b is b equals to mean of y minus slope into mean of x. that is 66 minus 6.1 into 3, that is equal to 66 minus 18.3, which is 47.7. Hence, this is the value of b. The intercept b is the value of y when x equals to 0. That means, in this example, 47.7 could be the best score when a student studies for 0 hours. Now, we want to know how much a student scores if he or she studies for 6 hours. We have our equation y equals to mx plus b, and here we have calculated all the values needed. So, y equals to mx plus b, that is 6.1 into 6 plus 47.7 equals to 84.3. Therefore, if the student study for 6 hours, he or she will score 84.3 marks. So this is the best case scenario. Let's see the example of linear regression in Python code. So first, let's import our libraries. This is step 1, and then import numpy as np. NumPy is used to create data arrays and it is for numerical operations. Now let's import another. Import matplotlib.py plot as plt. So matplotlib.pyplot will help to visualize the data and the fitted line. Next, we will sklearn linear model and then import linear regression. So we import linear regression, which is the regression model from scikit-learn. Next, we are step 2. Let me do like this, and then step 2 is about creating dataset, right? And then we'll create the dataset of x and y, where x is the study hours. So has study hours, and then variable x equals to np arrays, and let's give our data, that is 1 2 3 4 5, and then close the parenthesis and dot reshape and -1, 1. So here x is the hours studied, which is our input, and this is independent variable. So this will receives the data into the column vector. Another we have is scores. So scores, and then y equals to np.arrays, and then we have the marks is 54, 60, 66, 71, 79, and then so y is a scores obtained, which is the output, and this is a dependent variable. So this is our data set. Now let's create and train the linear regression model. That is step 3. Create and train the model. So model equals to linear regression, and then this. So we have created a linear regression model. Now we will train the model. Model dot fit x comma y. So this fit trains the model using the data. Next step is to make prediction. Let's say we want to predict the score for students who have studied for 6 hours. Therefore, step 4 is like make a prediction. So score predicted equals to model dot predict, and then we want to predict for 6 hours. So predict 6 will provide the predicted score for a student who have studied for 6 hours. Now let's print the result. Print and then score predicted for 6 hours of study, and then score underscore predicted, and then I will 0. Okay, now let's run this code. I got the error. sklearn dot linear. Oh, too many errors. Track np errors 1 2 3 4 sep. Sorry, errors. Okay, score predicted for 6 hours of study is 84.3. Now let's visualize our result. Therefore, step 5 would be, let me write here. Okay, hash step 5 equals to visualization, and then I'll plot scatter x comma y comma, and let's give color like blue, and then a label equals to actual data, and then close this. Another is plot dot plot x comma model dot predict x, and then color equals to red, and comma label equals to regression line. Okay, so here the scatter plots the actual data points and in blue color, whereas the plot draws the regression line predicted by the model in red color. And let's give x and y, like x label, then study hours, and then plot at y label equals to scores, and then plot title study hours versus scores, and then plot dot lesson, and then plot dot show. So labels and the titles are added for clarity, and so will display the plot. So let's run this. See, we get our result. So these blue dots are the actual data, and the red line represent the regression line. And we have predicted the scores for 6 hours is like 84.3. Advantages: very easy to implement, results are easy to interpret, great for small datasets, computationally fast. Disadvantages of linear regression: they are sensitive to outliers, they assume linearity, and it doesn't perform well on complex or non-linear data, and it can only predict numbers. Types of linear regression: simple linear regression. If there is only one independent variable, then it is known as simple linear regression. Multiple linear regression: when there are more than one variable, then it is known as multiple linear regression. So that's it for linear regression. We have learned what is linear regression, how it works, math behind it, and how to implement in Python, and its advantages and disadvantages. So if you found this video helpful, do not forget to like, share and subscribe my channel. Share it with your friends who are studying machine learning. Welcome back everyone. We are at day 6 of our machine learning series. In today's video, we are going to learn about polynomial regression. So let's get started. What is polynomial regression? Polynomial regression is an extension of linear regression where the relationship between the dependent variable and independent variable is more or less nth degree polynomial. In many real-world scenarios, the relationship between variables is often non-linear. Polynomial regression helps us to model this kind of curved data points by adding higher degree power of x. Polynomial regression equation. The equation of linear regression is y equals to b0 plus b1x plus e, where x is the independent variable, y is the dependent variable, b0 and b1 are the coefficients, e is the error. Similarly, the equation of polynomial regression is y equals to b0 plus b1x plus b2x square plus b3x cube plus bn xn plus error, where x is the independent variable, y is the dependent variable, b0, b1 to bn are the coefficients of polynomial, n is the degree of the polynomial, and e is the error. Example. Let's consider an example of predicting house prices where we analyze the relationship between the price of the house and the size of the house. The relationship between these two factors might not be linear. So let's see this table. Here we have two parameters. One is house size and the other is house price. As shown in this table, we see from 20 square meter to 70 square meter, the price of the house increases very fast, whereas after 70, the price of the house slows down. Now let's plot this in graph. So this is our data. When we see these data points, we realize that a linear or the straight line won't fit well in this situation. Therefore, for this type of data, we need polynomial regression. Quadratic polynomial regression equation. Now let's apply polynomial regression to model the relationship between the size of the house and the price of the house. Suppose if we try a quadratic model, that is degree equals to 2, which include both linear and the quadratic terms for better fit. The quadratic polynomial regression equation is y equals to b0 plus b1x plus b2x square. So by using this polynomial regression equation, it allowed the curve to bend and fit the data better. In this way, it will capture the nonlinear progression of the house price and its size. Now let's implement this and see in the Python code. Now let's practice polynomial regression in Jupyter Notebook. So hash polynomial regression. At first we'll import libraries. So import libraries, import numpy is np. So numpy is used to create data arrays and it is for numerical operation. Another is import matplotlib.pyplot as plt. So matplotlib.pyplot will help to visualize the data and fit it line. Next is I will write from sklearn.linear model import linear regression. So in this case we will import linear regression, which is the regression model from scikit-learn. Another is from sklearn.preprocessing import polynomial features. So here we import polynomial features class from the sklearn preprocessing module in scikit-learn. The next step is to create the data set. So create data set. The one parameter we have is house price, right? House price, and then I will represent as x, and then np dot array, and I will give the data like 20, 30, 40, 50, 60, 70, 80, 90, and then close this parenthesis, and then I will reshape and -1, 1 and parenthesis. So x is the house size, which is our this is house size. Okay, so x is the house size, which is our input, and this is independent variable. And another is house price, that is y equals to np dot array, and then I will give the values like 155, 190, 220, 245, and then 260, and then 265, 270, and closing the parenthesis. So this is y, where we store our house prices. So these are the data, and this dot reshape -1, 1, this code will reshape the data into a column vector. The next step is to transform features into polynomial degrees, like transforming features into polynomial, and then the degree is, let's say, 2. So I will write poly equals to polynomial features, and then I will mention the degree equals to 2. So this line means we are creating a polynomial features object named poly. Degree equals to 2 means it is for quadratic, and it will use like 1, x, x square, and if it is 3, then it's for cubic model. So we will use like 1, x, x square, x cube. But if it is 1, then it is for linear. And the next line is x underscore poly equals to poly dot fit underscore transform, and then x. So this will transform input data into polynomial form. Next step is to train the model. So train the model. Model equals to linear regression and then this. So this line will create a linear regression model object. Even though we are doing polynomial regression, we'll still use linear regression because technically polynomial regression is equal to linear regression on polynomial features. And then another is I will write model dot fit and then I'll give x poly and then y. So this fit means to train the model. Another step is to make prediction. So prediction y underscore prediction equals to model dot predict and then x poly. So after training the model has learned the best equation for our data, and this dot predict is used to make prediction using that equation. Another step is to visualize. So has visualize. So plot dot scatter and then x comma y comma and then I will give color equals to blue comma label equals to actual data and then close the parenthesis. So this scatter plots the actual data points and in the blue dots, and another is plt dot plot and then x comma y underscore red and then color equals to red and then label equals to polynomial regression. So this dot plot will draw the regression line predicted by the model in red, and then plot dot x label and equals to like house size and in square meter as square meter and then okay, this x label is for labeling x-axis, another is for labeling y-axis, y label, and this is like house price and in $1,000 and okay. Now let's do plt dot legend and then plt dot show. Okay, this show will display the plot. Now let's run this code and see what is the result. Here is error x underscore poly. Okay, this one poly dot fit underscore transform x. So here is the error, I think FORM. Yeah, so yeah, this is the result. See, we get the curved line, but if the degree of the polynomial is 1, let's see and run. See, we get the linear line, so it does not cover all of the data points. That's why we do the polynomial regression. like this. Polynomial regression advantages: more flexible. That means it is more flexible than linear regression. Better fit. It is better fit as it can capture non-linear trends in the data. Polynomial regression disadvantages: complex. They are more complex and computationally expensive for high-degree polynomials. Overfitting. High-degree polynomials can bend too much and fit noise. Hello everyone, welcome back to my channel. In today's video, we are going to learn about logistic regression in machine learning. So without further ado, let's get started. So what is logistic regression? Logistic regression is a supervised machine learning algorithm that helps us to predict categorical outcomes such as yes or no. Logistic regression is not used for regression problems. Instead, it's used for classification problems. Examples of logistic regression are: it helps us to predict categories such as whether an email is a spam or not, whether loan is approved or not, whether a student passes or fails. Therefore, logistic regression has output probabilities between 0 and 1 that are converted to either yes or no or 0 or 1. Equation. The logistic regression model uses the logistic function to predict the probability. First, let's see the linear equation. Linear equation is equals to z equals to b0 plus b1x, where x is the input variable, b0 is intercept, and b1 is the coefficient. So, to squeeze this z into a probability between 0 and 1, we use sigmoid function. Logistic regression equation. So this is the formula of the sigmoid function, where p is the probability of dependent variable, b0 is the intercept, b1 is the coefficients, e is the base of the natural logarithm, x is the independent variable. So if we plot this logistic regression equation, we will get an S curve. This is called sigmoid curve. You can see logistic regression function returns only values between 0 and 1 for the dependent variable. We divide into two categories, class 1 and class 2. 0.5 is the point to divide between two classes. Therefore, if p is greater than 0.5, then we predict it's class 1 or pass or S. Similarly, if p is less than 0.5, then we predict it's class 2, which means fail or no. Let's see an example of logistic regression. Suppose we decide the result of exam based on study hours. So here we have our data. Here input is hours studied and output is result, that is pass 1 or fail 0. As we see, the probability of passing is near 1 if students study for longer hours, whereas the probability of passing is near 0 if the student study for short hours. And around 3.5 or 4 hours, the probability crosses 0.5, and that is called decision boundary. Now let's practice logistic regression in Python code. Let's see how we can implement logistic regression in Python. First, let's import some libraries. So, has importing libraries. So import numpy as np. So numpy is used to create data arrays and it is for numerical operation. Another is import matplotlib dot pyplot as plt. So this is to visualize the data. From sklearn dot linear model import logistic regression. So this line will import logistic regression. Now let's create a data set. Therefore has data set and x equals to np.array, and then I will give 1, 2, 3, 4 and then 5, and dot reshape -1, 1 and then close the parenthesis. So here x is the hours study, which is our input, and this is independent variable, and another is y equals to np.array and and I will give 0 comma 0 comma 0 comma 1 comma 1 comma 1, and then this. So here y is where we store the results based on the study hours. Next is to create and train the model. As creating and training the model. Mode equals to logistic regression and then so this line will create logistic regression model object. Then another is mode dot fit and then x comma y. The mode dot fit is where training happens, and after training the model knows more study hours has high chance of passing. Next step is to predict. Therefore, as predicting, let's say for 4 hours, so probability equals mode dot predict underscore proba, and then I will give 4. So this will get the probability for 4 hours. Another is to print like probability of passing for 4 hours of study, and then I'll give probability 0 and then 1, close this parenthesis. So this probability 0 and 1, it gives the probability of class 1, that is pass. So this line will predict our result. Next step is visualization. So visualization plt dot scatter and then x comma y comma, and we'll give the color equals to blue, and comma will label, and let's say actual data and then parenthesis. So this line plots the actual points and it is denoted by blue dots. Another is plt dot plot and then x comma mode dot predict and underscore proba and x comma 1, okay, comma color equals to red, comma label equals to logistic curve. So this plot will draw the regression line predicted by the model and it is denoted by the red line. Next is plot dot x label and then study hours. So this is the representation for x-axis. Next is plot dot y label and then pass probability. So this is to denote y-axis. And let's do plot dot legend and plot dot show. So this line will display the plot. Now let's run this code. Error here, plot mode.fit xy. Okay, there is error. Let's fix this. Mode.fit xy. I think this is right. Ah, I got this. This is 6. Let's run. Okay, next is, okay, for this error I think I forgot to give parenthesis. Okay, let's run and see. I'm sorry. So let's fix this. Let me do like this. Now let's run. So this is our result. The probability of passing for 4 hours of study is 0.63, that is equal to like 63%. So this is the example of logistic regression. Yeah, now let's move to the another chapter. Types of logistic regression. There are 3 main types of logistic regression. One is binary logistic regression, multinomial logistic regression, ordinal logistic regression. Now let's see each of them. Binary logistic regression. This is used when the dependent variable has only 2 possible outcomes, and this is the common type of logistic regression. The examples are, we can categorize results as spam versus not spam. Similarly, pass versus fail, or yes versus no. Multinomial logistic regression. This is used when the dependent variable has more than 2 categories, unordered. The examples are the predicting the types of vegetable like broccoli, beans, eggplant, and so on. And another is predicting customers' preferred payment method, either cash or card or online. Ordinal logistic regression. This is used when the dependent variable has 3 or more categories with order. It takes order of categories into account. The examples are customer satisfaction. We can categorize as poor, average, good, or excellent. Similarly, we can categorize hotels ratings as 1 star, 2 stars, 3 stars, 4 stars, or 5 stars. Advantages. The advantages of logistic regression are, it's good for binary classification, it's simple and easy to understand, it is fast and efficient, it provides probabilities, not just class labels. Disadvantages. The disadvantages of logistic regression are, it's not good for very complex data. Similarly, it is difficult with multi-class problems, and it only works well when the relationship is roughly linear in the log odds. Applications. Logistic regression is widely used in medical field, banking, marketing, email filtering, fraud detection, weather forecast, remote sensing, insurance company, and so on. Okay, that's all for logistic regression. So today we have learned that logistic regression is used for classification, and it uses sigmoid function to output probabilities, and it is very simple and widely used in real world applications. Today we are learning one of the most fundamental algorithms in machine learning, that is the decision tree. Now let's start our video. So what is decision tree? It's a supervised machine learning algorithm, and it is a flowchart like model which makes decision step by step, and at the end of each path there is either a decision or a prediction. Let's see its example. Imagine a scenario where we are deciding whether to play outside or not. So first we might ask, is it raining? If yes, then stay inside. If no, then we may check another condition like temperature. So if temperature is greater than 24 degree, then play outside. Otherwise, stay inside. Therefore, this is how a decision tree works, by asking questions and splitting the data step by step. Decision tree structure. A decision tree is like a flowchart used to make decisions. There are different parts to it. We have root node. This is the topmost node of the tree and is the starting point, and it represents entire dataset. Decision node. These are the decision points inside the tree, and each node tests a condition such as age is greater than 20 or study hours is greater than 40, something like that. And based on the test, the data is split into different branches. Branches. A branch represents the outcome of test. It connects one node to another node. Leaf nodes. They are the end points of the tree, and a leaf node gives the final prediction or a decision. How does a decision tree work? The first step is to define the problem. For example, we want to predict will a person buy a car or not. We have data such as income level and credit score. Let's start with the root node. At first, the algorithm looks all the features and decide which one to split. Suppose if the best feature is income level, then root node equals to income level. Then let's create branches from the root node. From the income level feature, we can branch into high income, low income and medium income. If high, then a person will buy a car. If there is a low income, then he or she will not buy a car. But if the income is in the medium range, then we need to check another factor, that is credit score. It will be like a person will buy a car if there is a medium income and good credit score. Otherwise, he or she cannot buy a car. At the end of every branch, we get a final decision in leaf node. High income, yes to buy a car. Low income, no. Medium income plus good credit, then yes. And medium income plus bad credit, then the result is no. So this is how a decision tree works like. Let's see the tree with a real example. We have data such as a person with income equals to medium and credit score good. Then the tree will check if income is medium, then go to the credit score branch. If the credit is good, then the final decision, that is to buy a car. Therefore, the tree keeps splitting the data step by step until it reaches a clear decision. Entropy. It measures uncertainty and randomness in the data. The higher the entropy, more the information content. And the formula to calculate entropy is like this. Here P1 and P2 are the probabilities of classes. When a dataset has all the same outcomes or belong to one class, then the entropy is 0, which means pure. That is, there is no uncertainty left in predicting the outcome. Similarly, if the outcomes are evenly splitted or equal number of yes and no, then the entropy is 1 or high because we don't know which outcome to predict as it is uncertain. The example is like tossing a coin. We can get probability of tails like 0.5 or the probability of heads 0.5, and then if we calculate entropy in this case, it is equal to 1. Hence, there is a maximum uncertainty as we cannot predict when it is head or tail. But if we have 90% head or 10% tails, then at that time the entropy calculation equals to 0.469, which means it is less uncertain to predict than the earlier case. Information gain. Information gain let us know how much entropy is reduced after a split. The formula to calculate information gain is like this. Here, S is the original dataset, A is the feature, SV is the subset after splitting. So we calculate information gain for each feature, and to split we pick the feature with the highest information gain. Let's see an example of information gain. Suppose we have 10 students and 6 are passed and 4 are failed. Therefore, entropy before the split can be calculated like this, and it is 0.97. Now, if we split on study hours, we can group like Group 1 and Group 2. Group 1 is a student who study more than 5 hours, and in that group we have 5 pass and 1 fail, and its entropy calculation is 0.65. Similarly, Group 2 has the entropy as 0.81, and the weighted entropy after the split is 0.71. Therefore, the information gain is 0.97 minus 0.71, that is 0.26. So this tells us study hours is a good feature to split on. Let's see another example. Our dataset is to play tennis based on the weather. So this is our data. We have total samples 8, and we have here 5 yes and 3 no. And if we calculate the entropy, then entropy equals to 0.95. Now if we split by the weather, for sunny we have 3 samples, 2 no and 1 yes. Therefore the entropy will be 0.92. And for cloudy there are 2 samples, both are S, then the entropy is 0. And for rain there are 3 samples, 2 S and 1 no, and the entropy calculation is 0.92. So if we calculate the total entropy, then it is equal to 0.69. Therefore, the information gain is 0.95 minus 0.69, that is 0.26. Hence, the weather is a good splitting feature. Advantages: it works for the classification and regression. It's easy to understand and visualize. It handles both categorical and numerical data. Disadvantages: it is biased towards features with more labels such as ID numbers, unstable. That means small changes can alter tree drastically. In this video, I will explain the decision tree example in Python code. So let's start our video. Now let's practice decision tree in Python code. First, let's import the libraries. So step 1 is import libraries from sklearn.tree import decision tree classifier and then plot tree. So this decision tree classifier, it builds the decision tree model, and plot tree, it draws the tree so we can visualize it. Next is import matplotlib.pyplot as plt. So this will show the image. The step 2 is creating a small data set, and let's say features are like weather and then sunny equals to 0 and rainy equals to 1, and let's say another feature is wind, and if it is weak it is 0 and if it is strong equals to 1. So x equals to 0, 0. So this means sunny and then weak. Similarly 0, 1, it means sunny, strong. Another is 1, 0 and then it means rainy and weak. Next 1, 1 is it is rainy and then strong. Another is, let's say our target is to play tennis, and here yes, let's say s equals to 1 and no equals to 0, that is equals like sunny is equal to like yes and 1. Similarly rainy is equals to like no, it means 0. Y equals to 1, 1, 0, 0. So x is our input feature. Here each row is a scenario like weather and wind, where y is the output level whether to play tennis or not. And here we want the sunny, that is to play, which is yes, and rainy, that is don't play, which is no. Then step 3 is create and train the model. Model equals to decision tree classifier, and then criterion equals to entropy. So this criterion equals to entropy will tell the model to use the information gain to decide the splits. Next is model dot fit and then x comma y. So this will train the tree using our data, so it will learn the pattern. And the tree now learns the rule sun equals to yes and rain equals to no. The step 4 is to make a prediction. And then prediction equals to model dot predict and then 0 0. Let's take this one, and this means sunny and weak, right? And print, and then we'll play tennis. We'll play tennis, and then question mark, and then if yes, if prediction 0 equals to 1, else no. Okay, so we'll ask the model if weather equals to sunny and wind equals to weak, that is 0 0, can we play the tennis, like that. Then it predicts yes, since sunny equals to play. We'll see in the result later on. Now step 5 is to visualize. Plot dot figure and then figure size equals to 5 comma let's say 4, and so this will draw the decision tree. Another is to plot underscore tree and then model comma feature underscore names, and then I will write here weather and wind, and close this, and then comma class names equals to no, yes, and I will close this one, and field equals to true. Okay, so this feature names will label the node with the weather and wind, and class underscore names will label the result as yes or no, and then field equals to true will color the boxes to show the decision. Then plot dot show So this will display the image. Now let's run this. Yes. So here the root node is a weather and the leaf nodes are the final prediction, that is yes or no, and wind feature is not needed. Therefore, this is how we first made a tiny data set, that is weather and wind, then trained a decision tree and we tested it. Finally, we drew the tree to see how the decision was made, and it is yes to sunny and weak. Now let's see if it is like 1, 1. Let's run this. So it is also no, because the 1 means like rainy and strong wind. We are at day 10 of our machine learning series. In this video, we are going to learn about random forest, which is one of the most popular machine learning algorithm. So let's start our video. So what is random forest? Random forest is a supervised machine learning algorithm. It can be used for classification and regression problems in machine learning. Random forests are ensemble learning method as they are built from multiple decision trees. Random forests help to improve accuracy and reduce error as compared to single decision tree. That means the greater the number of the tree, the more accurate and the stronger the model will become. So this is how a single decision tree looks like. However, the random forest looks like this. It's the combination of multiple decision trees. Why random forest? Because it has higher accuracy. The final prediction is usually more accurate as the prediction come from different trees. It reduces overfitting. First, let me explain what is overfitting. Suppose we have a single decision tree which has every detail of training data and it performs well on this data. However, it may fail on the new data. This problem is called overfitting. Random forest reduces overfitting because it has many trees and each tree is trained on different random data set and its features. When it is combined, then the error or the noise cancel out, making our model work better. Random forest works for both, whether it is classification problem like predicting yes or no decisions or regression problem like predicting continuous numbers. Next is feature importance. Random forest tells which variables are more important in our dataset. And the last is it handles missing data and noise. Random forest handles missing data and noise. In some cases, trees might have incomplete data, however the forest as a whole still makes a good prediction. History of random forest. In 1996, Leo Bremen introduced bragging, that is bootstrap aggregating, to improve decision trees. In 2001, Bremen introduced random forest, combining bagging with random feature selection for better accuracy. How random forest works. So this is the structure of random forest. Now let's see step by step. First is to create multiple decision trees. That is, each tree is trained on bootstrapping. That means randomly selecting samples with replacement to create subset. That's why each tree gets different datasets like class 1 and class 2. Another step is to select random feature. At each split, only a subset of features is considered, and this step prevents all the trees from being identical and it reduces the correlation. Another step is to build trees and make prediction. So grow each tree fully so that each tree independently makes its predictions. And finally combine all the predictions. So for classification problem we choose the majority part, whereas for regression problem we take the average of different trees outputs. That means from this figure we have final predictions like class 1 and class 2, but here is the majority is class 2. So for instance, if it is a classification problem, then our final prediction is class 2. Hence, this is how the decision tree works. Now let's see the limitations of random forest. First is training time. The training time of random forest can be slow for huge datasets or large number of trees. Next is bias with certain features. It can be biased with certain features such as trees with so many categories, as well as highly correlated features can sometimes dominate the splits. The third is complexity and memory. As compared to a single decision tree, random forest has large memory uses and they are complex, so it has a lower training and prediction period. Overfitting possibility. With noisy data and very complex trees, it can still overfit slightly. Less interpretable. It is difficult to visualize and explain the random forest as compared to a single decision tree. Okay, that's all for random forest tutorial. We understand that random forest is a powerful and widely used in machine learning. It reduces overfitting and works for both classification and regression problem. In the next episode, I will explain the random forest with its example in Python. In the earlier video, we learned what is random forest in machine learning. In this video, we are going to see the Python implementation of the random forest. So let's start our video. The first step is to import the libraries. So step 1 is to import libraries from sklearn.ensemble. Import a random forest classifier. Random forest classifier. So this line will import the random forest model class. And next is from sklearn.model and then selection import train test and then split. So this will split the data into training set and the testing data set. Next we have is from sklearn.metrics import accuracy score. So this will import a function to measure the accuracy, like how many predictions the model got right or not. Next is import pandas as PD. So this library will create and manipulate the tabular data. Now the next step is to create the data set. We are going to write a code to check whether a person can buy a car or not based on the parameters like age or the salary. So let's create the data set. The step 2 is to creating a data set. So our data set equals to, we'll create here a dictionary. That's why, like age, one of the parameter is age, and then I will give the age like 20, 21, 24, 27, 31, 34, 41, 44 and 51, 56, 62, 65. So these are the ages, and another is salary. And then I will write here 22,000, 25,000, 30,000, 35,000, 40,000, 45,000, 50,000, 55,000, 60,000, and then 70,000, 75,000. Let me check. 1 2 3 4 5 6 7 8 9 10 11 12 3 3 6 9 65. Okay, here 65. One data is missing, that's why. Okay, next is our is to buy car, and then like 0 or the 1. 0 means no, and then 1 means yes. So let's write here 1 1 1 1 1. and then 1 1. Okay, this is it. So here yes means 1 and then no means 0. So let's close this, and then so this will create a Python dictionary containing age, salary and the by columns. Another is df equals to pd dot data frame and then data set. So this will convert the dictionary into pandas table. Next is x equals to df and then and we have is, I'm defining x and the y, and here salary and y equals to df by car, right? So x has the input features like age and salary that the model will use to learn, and y is the target vector that we want to predict. If it is a 0 then it is yes, if it is if it is 1 then it is yes, if it is 0 then it is no. Next step is to split the data set into training and the testing data. So step 3 equals to splitting data set into training and testing data. So let's give here x train comma x test comma y train comma y test equals to train like the earlier were split and then x comma y comma, and I will keep the test size equals to 0.3 comma and then random state, so equals to 42. Okay, let me explain this. This train, test and split, it will split the data into training and the testing data set, and then this test size equals to 0.3 means 30% of the data is used for the test data, whereas 70% of the data is for training data. And here another we have is random state 42. That means if we set the random state like example 42, then we are fixing the randomness so that the results are always reproducible. That means the same trees, same split and the same accuracy. But if we do not set the random state, every time we run the code we might get the different results. So due to like different split, different forest and slightly different accuracy. Overall it returns the 4 objects, that is x train, x test, y train and y test. The next step is to create the random forest model. So step 4 is to creating random forest model. Now model equals to random forest classifier, and then I will give n estimators equals to 10 and then random state equals to 42. So this will create the random forest object. Here n estimators equals to 10 means build 10 trees in the forest, and then random state equals to 42. It will fix the randomness as I explained earlier. So this is how we create the random forest model. Now let's move to the training. Step 5. Okay, dash training the model dot fit equals to x train, x underscore train, and then y train. So now this line will train the random forest for all the trees, and once the model is trained, it will learn the pattern from the training data, and the next is the prediction. So step 6 equals to like making predictions. Y prediction equals to model dot predict and then x test. So this model dot predict uses the trained forest to predict the label for new x test data, and y pred is an array of the predicted labels, that is 0 or the 1 for the test data. Then we will check the accuracy. So step 7 is checking the accuracy. Print accuracy is, and then I'll give the accuracy score. Accuracy score, and then I will give input as test and y will pred. Right. So this combine the predicted label y pred to the true labels, that is y test, and print the accuracy. And another step is to check for the new data. Let's say steps 8, and then is like predicting for a new data. Let's say is equals to 31, 35,000, and then closing the parenthesis. New data equals to 31, 35,000. Okay, another is I will write prediction equals to model dot predict and then new data. Okay, and print, then will he slash c buy a car? Yes, if prediction 0 is 1, else no. And then close this. So here new data is to create the new sample, and model.predict, it will predict whether this person will buy a car or not, and finally print the result is yes or no. Now let's run and see this code. Here is error. I don't need this. Yeah, again there is error. Here is also. So this is the result. Here the accuracy is 1. that means 100%. And will he or she buy a car? The result is no. Here we have given 31 A's and then the salary is 35,000. So if I do like here, like 35, and then salary is also a little bit more, like 60,000, then let's see. So the answer is yes. So this is the example of the random forest in Python. I hope you like this. In today's video, we are going to learn about one of the simplest algorithms in machine learning, that is k-nearest neighbor or KNN. So without further ado, let's get started. So what is k-nearest neighbor or KNN? KNN is a supervised machine learning algorithm used for classification and regression. It works by finding the k closest data points to new data point based on a distance metric like Euclidean distance. It then makes predictions based on majority vote for classification or average for regression. It is also called as a lazy learner because KNN does not build a model during training process. It just stores the data and makes prediction when it is required. Let's see an example of KNN. Suppose we have clusters of data like this. Here are two types of data, that are blue circles and orange diamonds, which are labeled as class 1 and class 2. Now, if we have a new data like this and we have to find out in which class it belongs to. For that, we have to find its nearest neighbor as shown in the figure. To calculate the nearest neighbor, we have different types of distance metrics, which I will discuss later on. So these are the nearest neighbors of our data. After that, we have to decide the value of the k. If it is 3 like this, then the majority will decide. Here, majority is 2, which are of class 1. Therefore, our data also belongs to class 1, that is blue circle. Hence, this is the basic concept of KNN. What is k in KNN? In KNN, k is the number of nearest neighbor the algorithm considers while making a prediction. Let's see an example. If we want to predict whether a new student plays basketball or tennis based on his or her height and weight, so if k equals to 1, we look at the closest student only. And if that student plays basketball, then it will predict basketball. But if k equals to 3, we look at the 3 closest students. If 2 students play basketball and 1 plays tennis, then the majority is basketball. Therefore, we predict basketball. Hence, the value of the k can be adjusted according to the type of our data, and choosing the right k is important. The small k is more sensitive to noise and can overfit, whereas the large k gives smoother decision, but it may lead to underfit. There are different distance metrics for different types of data. The most used formula in KNN is the Euclidean distance. Similarly, we have Manhattan distance, Minkowski distance. The most used formula in KNN is the Euclidean distance, and the choice of the distance metrics affect the KNN performance. The formula to calculate Euclidean distance is like this, and using this formula we calculate nearest neighbors. KNN algorithm. The first is the collection of data, and then choose the number of neighbors, that is k. The third is calculate the distance between new point and all existing data points. And the fourth is sort all the data points based on distance. And then choose the k nearest neighbors. Choose the majority class among neighbors if it is classification. If it is regression, take the average of neighbors value. So this is the KNN algorithm. Mathematical explanation. Now let's see KNN with some real example. Suppose we want to predict whether a person will buy ice cream or not based on temperature and humidity. Here is our data. One is temperature and the other parameter is humidity. And in buy ice cream column, if it is 1, then it is yes. That means he or she can buy ice cream. If it is 0, then it's no. Now we want to predict for the condition if temperature equals to 24 and humidity equals to 57. First, let's calculate Euclidean distances. For example, when the temperature is 40 and humidity is 70, we consider this as x2 and y2. And our x1 and y1 are 24 and 57. Then let's use the Euclidean distance formula and get the result as 20.65. In the same way, we calculate for all data and get like 13.60, 3.16 and 7.61. Now, if k equals to 3, then we choose the nearest distances as 3.16, 7.61 and 13.60. Here two values has no and one is for yes. That's why our prediction is also no, because majority vote goes for no. Therefore, a person cannot have ice cream on the condition where temperature is 24 and humidity is 57. So this is how we can make prediction in KNN. Advantages. It is very simple and easy to implement. It is versatile as it works with classification and regression. There is no training required because it is called lazy learner. It works well with small datasets. Disadvantages. Cost of dimensionality, that means it doesn't work with high dimensional data. Choosing the value of k can be tricky. Slow with large datasets as it computes distance to all points. It can be prone to overfitting. Real-life applications of KNN. It can be used for recommendation system for suggesting products by history of other users' purchase. Another is customer segmentation. We can group customers and analyze their shopping behaviors. It can be used for medical diagnosis for identifying different diseases based on various health measurements. Another is KNN can be used for spam detection. If there is a new email, then it is compared with existing spam and non-spam emails. After that, it decides whether it is a spam email or not. So these are some of the applications of KNN. There are so many other use cases of KNN in real life. Okay, that's it for KNN. We learned that KNN depends on its neighbors. That is why choosing the value of the k is really important. It is great for smaller datasets. In the next video, I will come with its implementation in Python. Hello and welcome back to the channel. In the earlier video, we learned about KNN or k nearest neighbor. In this video, we are going to practice KNN in Python code. So let's get started. The first step is to import the libraries. So let's import libraries. Step 1 is importing libraries from sklearn.neighbors import kneighbors classifier. Kneighbors classifier is the KNN algorithm for scikit-learn. Another is from sklearn.model selection import train test split. So this will split the data into training set and the testing set. Next we have is from sklearn.metrics import accuracy score. So this will measure how well the model predicts. And last is import pandas is PD. This will help to create and manage the dataset in the table format. Step 2 is creating a dataset. Step 2, creating a data set. Data equals to this one, and then our first input is temperature. So in this example, we are going to predict whether a person will buy an ice cream based on the temperature and the humidity, which I have explained in my earlier video. So let's keep the input for that condition. So temperature is one of the input. and here I will give 30, 25, 20, 22, 28, 35, and then 40, and comma, and next is like humidity, and sorry, 70, and then 65, and then 60, 50. These are random data. And 5, 80, 85, and then close. And next is the buy ice cream. Ice cream. 1, 1, 0, 0, 1, 1, 1. Okay. And finally I'll close this braces. So here we make a data set with temperature, humidity, and whether a person buy ice cream or not. Like 1 means yes, and 0 means no. df equals to pd dot data frame, and then data. So df is a table of this data. X equals to df, and then temperature, another is humidity, and y equals to df, and then buy ice cream, So here x is input, that is temperature and humidity, and y is the output, that is buy ice cream or not. Next step is to split the training and the testing dataset. So step 3 is train and the test split. Okay, then x train, and then x test, and then y train, y test, equals to train test split, and then x comma y comma test size equals to, I will give 0.3, and then random state equals to 42. Okay, so this will split the data into 30% for testing set and 70% for training the model. Next is step 4 is for creating the KNN model. So model equals to k neighbors classifier, and then n underscore neighbor equals to 3. So this creates a KNN model with k equals to 3. This will source for the 3 nearest neighbors to decide. Another is modeled dot fit, and then x train comma y train. So this will train the model using the training data. Step 5 is prediction. Now let's do the prediction. So y pred equals to model dot predict, and then we'll give the x test, then we will print accuracy comma accuracy underscore score, and then y test comma y pred. Okay, so this will predict the labels for the test set and the first one, and the accuracy score, you will compare the prediction with actual answers, and this will print the model accuracy. Step 6, predict for new case. So prediction equals to model dot predict, and then I will give the input like 24 temperature and the humidity is 57. Okay, then print will buy ice cream question mark comma yes, and then if prediction 0 equals to 1, else no. So this will predict for a new input, that is temperature equals to 24 and humidity is 57. Then if the model is output, then a person will buy ice cream. If it is 0, then a person won't buy ice cream. Now let's run and see. See, we get the accuracy score at 0.66, and in the will buy ice cream, the answer is no. Therefore, the result is 0. That means a person will not buy ice cream at the temperature 24 and humidity 57. Now, if I change the data into like temperature 31 and then humidity is like 71, let's run. So it is yes in this condition. What is support vector machine or SVM? It is an algorithm that classifies data by finding the optimal hyperplane which maximizes the margin between different classes. The larger the margin, the better the model performs. A support vector machine is a supervised machine learning algorithm used for classification and regression tasks. Now let's see how support vector machine work. For example, we have a data set of two classes. One is blue, another is orange. Now we have to find out our new data is either blue or orange. But we can have many decision boundaries like these lines. Therefore, we have to find which is the best decision boundary. For that, the main objective of SVM is to find the maximum distance from both the classes, and that is our optimal hyperplane. There are some key concepts of SVM. One is hyperplane, support vector, margin, hard margin, soft margin, kernel, C parameter, hinge loss, dual problem. Now let's discuss each of them. Hyperplane. It is a decision boundary that separates different classes of data. Here, the green line is a hyperplane. It is represented by the equation wx plus b equals to 0 in linear classification. In 2D, it is a straight line, whereas in 3D, it's a plane. But in higher dimension, it is called the hyperplane. Support vectors are the closest data points to the hyperplane, and they define the position of the hyperplane. Margin. It is the distance between the hyperplane and support vectors, or the closest data points from each class. SVM tries to maximize this margin to make the model more robust. Hard margin. In hard margin, there is no misclassification allowed. That is, it only works if the data is perfectly separable. Soft margin. In soft margin, it allows some misclassification for better generalization. It is a technique to handle nonlinear data by transforming it into a higher dimension. C parameter. It controls the trade-off between maximizing the margin and minimizing classification error. Small c means wider margin, that is more classification. Large c equals to narrow margin, means fewer classification. Hinge loss. It is the function that SVM uses to measure error. Loss equals to 0 if point is correctly classified and outside margin. Loss is greater than 0 if point is misclassified or too close to the boundary. Dual problem. It is an alternative way to solve SVM using optimization. Here, only support vector matters in this form, making SVM efficient. Workflow of SVM. First is input data, that is to collect and prepare the dataset, such as features and labels. For example, temperature and humidity are the features, whereas buy ice cream is the labeling. Next is feature scaling. SVM is sensitive to scale of the features, thus it has to normalize the data so all the features contribute equally. The third is choosing kernel function. It decides how to separate the data. Linear kernel is used if the data is linearly separable. Polynomial or RVF kernel is used if the data is non-linear. Setting parameters. C regularization control margin versus error trade-off. Gamma controls the influence of each data point for RVF control. Training the model. SVM finds the optimal hyperplane that maximizes margin, and it identifies the support vectors that define the boundary. Prediction. In prediction, it uses the trained SVM to classify new data points, for example, to decide which side of the hyperplane they fall on. Evaluation. It measures the performance with metrics such as accuracy, precision, F1 score. Therefore, this is the workflow of SVM. Now let's move to the another chapter. Types of SVM. Linear SVM, non-linear SVM, SVM for regression. Linear SVM is used when the data is linearly separable. That is, when the data points of different classes can be separated by a straight line or a hyperplane. Non-linear SVM, it is used when the data is not linearly separable between two classes by a straight line. Non-linear SVM applies the kernel functions to transform the data into higher dimension where it can be separated. SVM for regression. Instead of classification, SVM can be adapted for predicting continuous values, for example, predicting house prices. Why SVM matters? Robust to outliers. SVM focuses only on the closest points, so noisy points far from the margin don't affect the model too much. Effective in high dimensions. SVM works very well in high dimensional space, that is, when the number of features are large, even if there are few data points. That's why it is great for image classification. Versatile. SVM can handle nonlinear data using kernel functions like RVF and polynomial. Maximizes margin. SVM reduces the risk of overfitting by finding the hyperplane that maximizes the margin, and it also improves the prediction on new data. Applications. The applications of SVM are in various fields. Some of them are in bioinformatics. SVM can be used for classifying genes or DNA sequences, such as predicting protein function from genetic data. Face recognition. It can be used for verifying faces in security systems. Text classification. SVM can be applicable for classifying emails as spam or non-spam emails. Image classification. SVM is used for classifying objects in images, such as detecting tumors in MRI scans. Handwriting recognition. It can be used for recognizing digits or letters from scanned documents. Okay, that's all for support vector machines or SVM. We understand that SVM is a supervised learning algorithm that finds the best boundary between classes, and it works by finding support vectors and maximizing the margin. It can be used in real life scenarios such as medical diagnosis, spam detection, and so on. Thank you. In this video, we are practicing SVM in Python. So without further ado, let's get started. Now let's import the libraries. Step 1 is importing libraries. Import pandas is pd. So this library is used to handle data in table format. Another is import numpy as np. So numpy is used for numerical operations and grid creation. And another is import matplotlib.py plot as plt. So this is used to create visualization. Another is from sklearn.svm import svc. So this support vector classifier helps build an SVM model for classification problem. Next is from sklearn.model selection import train test split. So this helps to split out data into training and the testing sets. Next is sklearn.metrics import accuracy underscore score. So this will check how accurate are the model's predictions. So this is how we import libraries, and now we are going to create a simple data set of students, and we want to find out whether a student will pass or fail. And our data set will include study hours, sleeping time, pass or fail data of the students. The more they study, there is a high chance of passing. However, if they sleep more and study less, then there is a high chance of failing. So let's write here. Step 2, creating data sets. Data equals to, one is we have study hours, and let me give 1 2 3 5 6 7 8 9 and then 10, then comma. Another is sleep hours, nine, 8, 8, 7, 6, 6, 5, 5, 4, 3, and then comma, pass equals to like 0, 0, 0, 0, 1, 1, 1, 1, and then 1, again 1. Okay, so this is our data set. Here is study hours, so how many hours the student have studied, and sleep hour is how many hours the student slept, and pass, it will determine whether they pass or not. If it is a 1, then yes, and if it is 0, then it's a no. Now let's convert this dictionary into pandas data frame. df equals to pd dot data frame and then data. Okay, next step is splitting the features and the target. Next is step 3. Step 3, splitting features and target. So x equals to df and then study hours comma and then sleep hours. Okay, here x is a feature, that is the input values like study hours and sleep hours. Similarly, y equals to df and then pass. So here y is the target, that is the output label we want to predict, such as pass or the fail. Now let's split the data into training and the testing sets. So step 4, splitting the data. X train comma x test comma y train comma y test equals to train test split and then x comma y comma test size equals to 0.3 comma random state equals to 42 and then close this. So here we have splitted the data into 70% for the training the model and 30% for testing its accuracy, and random state equals to 40 ensures the split is always the same. And the step 5 is creating and training the model. Model equals to SVC kernel equals to linear and then close this, and model dot fit and then x train comma y train. So here SVC creates a support vector classifier and kernel is linear, means the model will try to separate data using a straight line. So this will train the model with the training data, and SVM will try to find out the best line which separates the pass and fail students with the maximum margin as possible. That means the line should be as far as possible. So after training, let's make prediction for the testing data set and find its accuracy. Has step 6 and then making prediction and finding accuracy. Y pred equals to model dot predict and then X test. So here the model predicts the outcomes for the test data, that is X test, and I will print accuracy and then accuracy score like Y test and Y pred. Okay, so this will calculate the accuracy of the model. It compares predicted results Y pred with actual result Y test. So if the accuracy is high, then our SPM is correctly classifying the students. Now let's predict for the new data. Step 7, new prediction. Okay, new data. So I'm giving here new data like 4,6. So here we are trying to test the model with a new student data such as study hour equals to 4 and sleep hour equals to 6, and then I will just prediction equals to model dot predict and then new data, and I will print this, print like student pass and yes if let me write here, yes, if prediction 0 equals to 1, else no. Okay, so here the model will predict if the output is 1, then it is yes, which means that students will pass, but if the output is 0, then it is no, that means student will fail. And then model will decide based on which side of the decision boundary the point lies in. Another is visualization. So step 8 equals to visualize the decision boundary. Okay, so plot dot figure and then I'll give the figure size equals to 8,6. So here we are plotting the figure. Here 8 and 6 are the width and height of the plot area. And next is plot scatter, like plot dot scatter and then X train and study hour and X train sleep hours, sleep hours, and then Y equals to, I will explain this later, Y train C map equals to coulomb, and S equals to 80, and label equals to training data. Okay, this is the function that creates the scatter plot. We know x train gives the x-axis values, that is study hours, and x train sleep hours is the y-axis value. The color C of each point depends on its class level, example 0 or the 1. Hence the point belonging to different classes have the different colors. C map equals to coulomb means it defines the color palette, and S equals to 80 is the size of the point, and the label equals to training data gives the label name for the plotted data. Therefore, basically this draws a scatter plot showing student data. Now, another is here x mean comma x max equals to x study hours dot mean -1 comma x and then sleep hours dot max +1 sorry, here should be study hours. Study hours, okay, max +1. Similarly, let me copy this and then I will write here y mean y max x sleep hours dot mean -1 x sleep hour dot max +1, and then xx comma yy equals to np dot mass grid and then np dot arrange and then x mean comma x max comma 0.1 comma and np dot arrange y mean comma y max comma 0.1 and then this. So this will create a grid covering the entire graph, and each point on the grid will be used to determine if it is pass or failed region. Okay, next is z equals to model dot predict np dot c underscore xx dot dot reveal and then yy dot reveal okay, this is to predict the class as a pass or fail for every point on that grid. Next is z equals to z dot reshape and then xs dot shape. Okay, this will reshapes for displaying as a smooth background color. Next is plot dot contour and then xx comma yy comma z comma c map equals to cool warm and then alpha equals to 0.3. Okay, plot dot x label equals to study hours and plot dot y label equals to sleep hours. Okay, I will not keep like this. And plot dot legend and then plot dot show. Okay. Okay, now let's run this. Okay, we get the result like this. See, we get the boundary line. The red region depicts the student who pass, that means who studied more and sleep less, and the blue region means who fail, that is the students who studied less and slept more. And the decision boundary here is like 50-50 around. And our new data 4 and the 6 falls just near the border. Since it's slightly towards the pass region, then the model predicts the yes here, and the accuracy is 1, which means the model correctly predicted all the test cases. Okay, this is the example of SPM in Python. Today we are going to explore about PCA or Principal Component Analysis. This is one of the most popular techniques in machine learning. So without wasting our time, let's start our video. Principal Component Analysis or PCA. It is a statistical method that reduces the number of dimensions in a dataset while preserving the most important information in a dataset. PCA is an unsupervised method. That means there is no need of label data to find the patterns. In simple terms, it takes large data with many variables and find how those variables relate. And then it creates new variables called principal components, which are the combinations of original features and the most important features in the data. Here is the example of PCA. Suppose we have 100 students with features like study hours, attendance, exam scores. Here, all of these features are related to each other. Therefore, instead of using all three separately, PCA can combine them into one principal component, and that represents the overall performance of each student. This one feature can describe all, and it reduces the complexity in the dataset. Now, let's see why we need Principal Component Analysis or PCA. We need PCA to visualize high-dimensional data. As we know that we humans can only visualize data in 2D or 3D. PCA can be used to visualize high-dimensional data into 2D or 3D. Therefore, it will be more easier to understand, and it is commonly used for exploratory data analysis. Another is to simplify the models. When the datasets have too many features, models can become complex and the time required for training becomes larger. Therefore, PCA helps by reducing the number of features while preserving the important information. Next is to prevent overfitting. Sometimes high-dimensional data can lead to overfitting. That is like when model becomes complex and fit the noise in the data. Hence, reducing dimensions through PCA helps model generalize better. We need PCA to remove redundancy. Many datasets may contain similar or noisy data. This kind of redundancy can be removed using PCA filters without significant loss of information. Hence, these are some of the reasons that we need PCA or Principal Component Analysis for handling various datasets in machine learning. How PCA works? The step 1 is to standardize the data, and the step 2 is compute the covariance matrix. Step 3 is compute eigenvalues. Step 4 compute eigenvectors. Step 5 sort eigenvectors by eigenvalues. Step 6 choose top k components, select principal components. Step 7 transfer the data. Now let me explain this by giving the real example. Suppose we have a simple data set like this. Here we have x1 is 2034 and x2 is 0113. Now let's see how to compute PCA for this. As I explained earlier, the first step is to standardize the data. The formula is like this. Different features might have different measuring scales. Therefore, we have to normalize the data first. This ensures every feature has a mean equals to 0 and a standard deviation equals to 1. Now, let's compute mean of each features. We have this original data is x1 and x2, and x1 bar equals to 2 plus 0 plus 3 plus 4 by 4, that is 9 by 4, which is equal to 2.25. Similarly, x2 bar equals to 0 plus 1 plus 1 plus 3 by 4, that is equals to 5 by 4, which is 1.25. Therefore, our mean vector x bar is 2.25 and 1.25. Next is to subtract the mean. So, we have to subtract the mean from each data, that is x new equals to x minus x bar. Here, each row is the original point minus the mean. So, we use this for both x1 and x2 data. Hence, the x new matrix is equals to 2 minus 2.25, the first column, and 0 minus 2.25, 3 minus 2.25, 4 minus 2.25, and the second column is 0 minus 1.25, 1 minus 1.25, 1 minus 1.25, 3 minus 1.25, and the resulting matrix x new is like minus 0.25, minus 2.25, 0.75, 1.75, and another column is minus 1.25, minus 0.25, minus 0.25, 1.75. So this is the x new matrix. And the step 2 is to compute the covariance matrix. The formula to calculate covariance matrix is like this. So in order to calculate the covariance matrix, we have to do the multiplication of x new matrix with its transpose. Here, x new is the dataset matrix and xt new is the transpose matrix, and n is the number of elements. We have n equals to 4. So n minus 1 is 3. Therefore, we divide by 3. Calculating this, we get C equals to this matrix. These values are rounded to 8 decimal. Hence, we get C11 equals to 2.9167, that is variance of x1. C22 equals to 1.5833, variance of x2, and C12 and C21 equals to 1.25, that is covariance between x1 and x2. The step 3 is to compute eigenvalues. Using the equation determinant of C minus lambda I equals to 0. Here lambda is the eigenvalue and I is the identity matrix. And solving this, the result is like this. And if we calculate this matrix, we get two values. Lambda 1 equals to like this and lambda 2 equals to like this. Now it is very important to think which eigenvalue is used to find eigenvector. Here lambda 1 has more variance than other. That's why we choose this value to find out eigenvector. Now step 4 is to find corresponding eigenvectors. So here is the equation for this. Here v1 and v2 are the eigenvectors. And we put the value of lambda 1 or lambda 2, which we chose earlier in the equation, and we get the value for v1 and v2 by solving the shown matrix. Step 5 is to find the principal components. First, sort eigenvectors by descending eigenvalue. Put them as columns of matrix W, and the matrix is like this. Therefore, the principal component is the multiple of x new and the w. And then PC equals to the multiple of two matrices. Computing this, we get this new matrix PC equals to minus 0.8575 minus 2.0580, 0.5145, 2.4010, and the next column is minus 0.9432, 0.9432, minus 0.6002, 0.6002. The first column is the coordinate along PC1, that is the most important direction, and the second column is the coordinate along PC2. One-dimensional representation using only PC1 is the first column of PC, that is minus 0.8575, 2.0580, 0.5145, 2.4010. Therefore, we reduce these original x1 and x2 features into single dimension. That is, the x1 and x2 are reduced to PC1. So this is how we calculate PCA. The applications of principal component analysis or PCA are data compression. It is like reducing the dimensionality of data such as of images while keeping important information. Data visualization. It can be used to visualize multidimensional data. Noise reduction. PCA helps to remove noise by selecting important features and excluding others in the dataset. Bioinformatics. It can be used to analyze high-dimensional gene structures. Pattern recognition. PCA can be helpful to find patterns of the data in large dataset. Okay, that's it for principal component analysis. If I summarize it, PCA helps us to find the most important patterns and compresses the information into fewer dimensions. That means it reduces the dimensionality while preserving the most information. It is very useful for improving machine learning model performances. In this video, I am going to explain PCA in Python code. Without further ado, let's get started. As we have learned in our previous video that principal component analysis or PCA is a dimensionality reduction which simplifies complex dataset by reducing the number of features. Now let's implement principal component analysis in Python. I am going to use a simple dataset with two features. One is height and another is weight. Now let's start. The first step is to import necessary libraries. So step 1 is importing libraries. Import pandas as PD. Another is import numpy as NP. From sklearn.preprocessing import standard scalar, and from sklearn.decomposition import PCA. Import matplotlib.py plot as PLT. Now next step is we'll make a small dataset with two features, that is height and weight. So step 2, creating a simple data set. Data equals to, and then I will write height IGST, and then I will keep the data as 149, 150, 151, 153, 160, 170, 180, 190, and then weight is 50, 50, 52, 55, 60, 65, 80, 85. And then close this. Let me check. 1 2 3 1 2 3 1 2 3 1 2. Okay, nice. Now next is df equals to pd dot data frame and then data, and let's print df. Okay, now let me run this. Okay, here we have our original data. See, this shows that as height increases, weight also increases. That is a positive correlation. Next step is to standardize the data because the features of height and weight have different scales. PCA, it works best when the data is scaled, that is when mean equals to 0 and standard deviation is equals to 1. So let me write here again. Step 3 is standardize the data. Scalar equals to standard scalar, and then scaled data equals to scalar dot fit transform, and then df, and I will print standardized data /n, and then scaled data. Let's run this. So this is our scale data, and our next step is to apply PCA algorithm. Step 4, applying PCA algorithm. We are applying PCA algorithm to reduce to one principal component that captures most of the important information. Hence, like PCA equals to PCA, and then I will give the n underscore components equals to 1, and then principal underscore components equals to PCA dot fit underscore transform equals to scaled underscore data print, and then principal components, and then I'll copy this one, and then principal components. Let's run. So these are the principal components. Here basically PCA, it finds a new axis, that is principal component 1, which explains the maximum variance in the data, and we also reduce the two-dimensional data to one-dimensional, since both features height and weight are strongly correlated. Now next step is to visualize the original data and the PCA line. So step 5 is visualization. plot dot figure equals to figure size equals to 8 and 6. The original data plot dot scatter and df height and then df weight and color equals to blue, comma s equals to 100, and then label I will give like original data points, and then this one has plotting ECA direction. So that is the first principal component, and mean I'll calculate mean np dot mean, and then I'll give a scaled underscore data axis equals to 0, and then vector equals to pca dot components underscore 0. So I will drawing PCA direction line, scale underscore factor equals to let's like 50. So this scale factor just stretches out visually, so we can see clearly where PCA is pointing, and we can adjust to the value. And then plot dot arrow mean 0, comma mean 1, and then vector 0 into scale factor vector 1 scale factor, and then color equals to red, comma width equals to 0.5, label equals to PCA direction. Now plot dot x label and then standardize height, and then plot dot y label standardize weight, plot dot title PCA visualization, plot dot legend plot dot grid, and then I'll give a grid true here, and then plot dot show. Okay, now let's save and run this program. Okay, this is our PCA visualization. Here this red arrow shows the principal component direction, that is the line of maximum variance, and the blue points are original standardized data, and the PCA line shows where the one-dimensional projection lies. Next is to find the explained variance. So step 6 is explained variance. Print explained variance ratio PCA dot explained underscore variance underscore ratio. Okay, now let's run and see. So our variance ratio is 0.995447. This means that 99.5 of the total variance is obtained by one principal component. Hence, we have successfully reduced the dimensionality without losing much information. Okay, this is the example code of principal component analysis, or PCA. We got to know PCA helps in dimensionality reduction. It finds new features called principal components, and this can be used for data compression, noise reduction, and visualization of high dimensional data. Today we are learning one of the most powerful machine learning algorithms, that is naive-Bayes algorithm. So let's get started. Now let's understand what is naive-Bayes. Naive-Bayes is a supervised learning algorithm, and it is a probabilistic classifier that makes prediction using Bayes theorem, and it assumes that features are independent of each other. Naive-Bayes uses probability to make decisions. For example, while finding an email spam or not, we can use like, is this email spam or not spam? Similarly, in classifying reviews, we can use such as, is this review positive or negative? And it picks the class with the highest probability. Why it is called naive? Because naive-Bayes makes one strong assumption, that is, all features are independent of each other. That means the presence of one feature does not affect other features. For example, in spam detection, if an email contains the words such as money, free, win, discount, naive-Bayes assumes these three words are unrelated to each other. But in reality, they are strongly related to each other. This assumption is naive, but surprisingly, the algorithm still performs extremely well in real applications, especially in text classification. Bayes theorem. The mathematical formula for Bayes theorem is as shown in this expression. Here, Py is prior probability, the initial probability of y before seeing any evidence. Px is the marginal probability of observing x. Probability of x by y is likelihood probability of observing x given that y is true. Py by x is posterior probability, that is the probability of hypothesis y given that x is true. Naive-Bayes picks the class with the highest posterior probability. Why naive-Bayes works even when the assumption is wrong? Even though the features are not independent to each other, naive-Bayes still works because it reduces the model complexity because of independence assumption. For large text datasets, work dependencies matter less. The algorithm focuses on relative probabilities rather than perfect mathematical accuracy. It performs well even with the small datasets. And it is very fast, and that's why it is good for large datasets. Therefore, naive Bayes is used in spam detection, sentiment analysis, topic classification, and so on. Types of naive Bayes. Gaussian naive Bayes. It is used when features are continuous, such as temperature, height, weight, and so on. It assumes data follow a Gaussian or normal distribution. Next is multinomial naive Bayes. It is used when features represent counts or frequency of occurrence. For example, word counts in NLP in a spam detection process. Bernoulli naive Bayes. It is used for binary, that is yes or no features. For example, to classify whether a word appears in an email or not. Therefore, these are the types of naive Bayes. Now let's move to the another chapter. Advantages. It is extremely fast as training time is just counting the features. It requires very little training data, so it works even with small datasets. It can perform well for high dimensional data. That means it is great for datasets with thousands of features like word frequencies. It performs great for text classification. That's why it is used in spam detection, sentiment analysis, and so on. Disadvantages. It assumes feature independence, but in reality, features are rarely independent. It has zero probability problem, and this is solved by using smoothing. This method struggles when the features are highly correlated. Here, continuous data must follow the normal distribution. If the distribution is different, performance drops. Applications. It is used in spam detection, such as counting how often words appear in spam or not spam. And recommendation system. It is used for predicting user interest based on their behavior. Sentiment analysis. It can be used for classifying reviews such as positive or the negative. It is also used in document classification, such as to classify news articles into sports, politics, tech, and so on. Similarly, it can be used in medical diagnosis, such as predicting disease based on their symptoms, and face recognition, weather prediction, and so on. Okay, that's it for naive Bayes algorithm. We understand that naive Bayes is a simple and powerful machine learning algorithm, especially for text processing. In the next video, we'll implement naive Bayes in Python and explain every steps. In the earlier episode, we discussed about naive Bayes algorithm and how it works. In this video, we are implementing naive Bayes in Python. So let's get started. In this Python code, we are writing code for predicting whether to buy ice cream or not based on the temperature. Hence, the first is to import the libraries. As step 1 is to importing libraries from sklearn.naive_Bayes import Gaussian NB. So here we choose Gaussian NB because our feature, that is temperature, is a continuous numerical data. So naive Bayes is perfect. Step 2 is creating a small data set. So that first we have like temperature in Celsius, so temperature is a feature, and we give like x equals to some values like 32 comma, and then another is 21 comma, is 22 comma, 25 comma, 17, sorry, and then 27 and 40. Okay, this much. So these are the temperatures. Now let me give y as whether to buy ice cream or not. That's why buy ice cream if it is s, then equals to 1. If it is no, equals to 0. Here, okay. So y equals to 1 0 0 1 0 1 comma 1. Okay, if temperature is 32, then it is yes. If temperature is 21, no. 22, no. And then 25, yes. 17, no. 27, yes. And 40, yes. So this means if the temperature increases, people are more likely to buy ice cream. Next step is to create and train the model. So step 3, creating and training the naive Bayes model. Okay, then we have model equals to Gaussian NB and this. So this creates naive Bayes model, and then next step is to model dot fit and then x comma y. So this is for training. This will learn how temperature affect the buying behavior or the relationship between temperature and buying ice cream. And next step is step 4 is to make prediction, like making a prediction, and then prediction equals to model dot predict, and then I will give some value like 24. Okay, so this helps model predict. Now I can print, like print, like buy ice cream at 24, and then I will like this, and if it is yes, then prediction, if prediction and then 0 equals to 1, else no. Okay, so here we ask the model, if the temperature is 24, will people buy ice cream or not? The model returns 0 and 1. Next step is step 5, finding the probabilities of yes and no. Okay, then prob equals to model dot predict and then proba, and then I will give of 24. Okay, and this will, I will print the probability of the no and then S. Okay, probability of no is probab 0 and then okay, similarly probability of yes and then 0 and then 1. Okay, so this will give me the probability of the no and then S. Let me run this. Yes, so I had questions, will we buy ice cream at 24 degrees Celsius? Then the answer is yes, because the probability of yes is higher than the probability of the no. Now let me check for 17. 17, here also let me write 17 and then 17. Now let's run and see. I get no as answer because the probability of the no is greater than the probability of yes. So this is how we use naive Bayes algorithm in Python. Today we are going to learn about k-means clustering. So without further ado, let's start today's video. Clustering. Before explaining the k-means clustering, first let me explain what is clustering. Clustering is basically grouping similar data together based on their patterns or structures. The real life examples are grouping flowers by their shapes or grouping customers by buying habits. K-means clustering. K-means is an unsupervised machine learning algorithm. It divides data into K clusters, and each cluster has a center point called centroid, and points belongs to the cluster whose centroid is closest to them. K-means algorithm. Now let's see the basic algorithm of k-means clustering. The step 1 is choosing the number of clusters k. For example, the clusters can be k equals to 4, 3 or any number. Next step is to initialize the centroid. That is, we randomly pick k points as the first centroid. And the third step is assign points to the nearest centroid. That means for each point we find distance to each centroid and then assign it to the closest one. The distance is calculated using Euclidean formula. Then step 4 is to compute new centroids again. Here the centroid is calculated as the mean of all points in that cluster, which is given by this formula. Step 5 is to repeat step 3 and step 4 until the centroid's movement is very small. Last step is to get final k clusters. Therefore, this is the basic algorithm for k-means clustering in machine learning. How to choose the correct k? As we know that in k-means clustering, deciding the correct k is not that easy. So let's see how to choose ideal k. The first step is to run k-means with assigning k equals to 1 to 10. Then we plot the within cluster sum of squares or WCSS against increasing k values. And then the next step is to find the elbow point where improvement slows down, and that k is the best. So this is how we choose the correct k in k-means clustering. We use k-means clustering for image compression, that is to reduce number of colors in an image using color clusters. Next is for document clustering, such as to group similar articles of sports, politics, tech and so on. Next is for market basket grouping, such as grouping products bought together. And last we have is for customer segmentation. For example, banks and stores classify their customers based on their spending. Therefore, we use k-means clustering for these reasons. Advantages of k-means. It works well on large datasets. It requires low memory usage. It is easy to interpret. It is simple and fast. It can find well-separated clusters. Hence, these are some of the advantages of k-means clustering in machine learning. Now let's move to its disadvantages. Disadvantages of k-means. It is sensitive to outliers. K-means fails when clusters have different sizes. Random initialization in k-means can affect final results. In k-means, we must choose the value of k manually. Therefore, these are some of the disadvantages of k-means which we should be aware of. That's all for k-means clustering. We understand that k-means is an unsupervised clustering algorithm and it divides data into k groups using distance. It is fast, simple, and widely used in the industry. In the earlier video, we have learned about k-means clustering. In this video, we are going to implement k-means clustering in Python code. So without further ado, let's get started. Now let's import the important libraries. Importing the libraries. First is import numpy as NP. So we use numpy to store our data. Next is import matplotlib.pyplot as plt. So we use this to draw clusters and centers, and from sklearn.cluster import k-means. So we import the k-means algorithm from scikit-learn so we can easily run clustering. Next step is to create the dataset. So creating a data set. So we are creating 3 clusters. X equals to np.array, and then I will give like cluster 1, it's like 1, 2, and then 2, 1. So these are the data for the cluster 1. Now let's give data for the cluster 2. Cluster 2. So these are the data for the cluster 2. Now let's give for cluster 3. So basically this line creates a dataset with 18 numbers, and each point has x and y coordinates. These numbers are separated into 3 groups. Cluster 1, numbers from 1 to 3. Cluster 2, numbers from 7 to 9. Cluster 3, numbers from 14 to 15. So the model can clearly find the 3 clusters here. Now next step is to create the k-means model. As creating the k-means model, and then k-means equals to k-means and n clusters equals to 3. So here we are asking k-means to find 3 clusters in our data. Now next step is to train the model. Training the model. K-means dot fit and then x. So this is the most important step. Here the process of k-means algorithm happens actually, like choosing 3 random points as cluster points and then assigning every data point to the nearest center, then moving each center to the average position of its points and then repeating until the center stops changing. Basically, here the algorithm of the k-means clustering happens. Next step is getting each point's cluster number, like getting each point's cluster number. Labels equals to k-means dot labels and then underscore. After this we get the cluster centers. Getting the cluster centers. Centers equals to k-means dot cluster underscore centers. Yeah. So this gives the middle point of each cluster. Next we will draw the data points. So drawing the data points, we'll use the scatter plot. Scatter and then x comma 0 comma x colon 1 comma c equals to labels. So here this means all the x values, whereas this means all the y values, and this will, so this means the color points based on the cluster number. Basically this draws all the data points in 3 colors. Next step is to draw the cluster centers. As drawing the cluster centers. Plot dot scatter centers colon 0 and then, so this means the x coordinate of the centers, and whereas I will give for so this shows the y coordinates of the center. S equals to 200 and then marker equals to anything like x, and then okay, this s is equals to 200, it makes the points large, whereas this marker it shows the center as like x. So this mark shows each centroid clearly. Now showing the final plot dot show, so this display the full clustering. Now let's run. Something is missing here. Okay, here is error. I forget to close this. Let's run again. I think it's okay. Oh yeah, see, we get this final result. So we have 3 clusters here, and with the different colors, like this one, green and yellow, and we have these big X markers. That's it is a cluster center, and data is nicely separated into 3 groups. So this is the example of the K-means clustering in Python. In this video, we'll discuss about hierarchical clustering. Now let's dive into it. Hierarchical clustering is an unsupervised machine learning algorithm, and this groups data points by building a tree-like structure called dendrogram, and it shows how clusters are formed step by step. The main thing about hierarchical clustering is, instead of fixing the number of clusters in advance, it shows all possible groupings from a small cluster to one big cluster. Types of hierarchical clustering. There are 2 main types of hierarchical clustering. One is agglomerative hierarchical clustering, which is bottom-up approach, and the next is divisive hierarchical clustering, which is top-down approach. Now let's discuss each of them. Agglomerative hierarchical clustering. It starts with each data point as its one cluster, then it repeatedly merges the closest clusters, and finally it ends with one large cluster. And the merging process is based on distance measures such as single linkage, complete linkage, or Ward's method. And this is the most commonly used hierarchical clustering. Now let's see how it works. Here each data point is a cluster. Then we find the 2 closest clusters and then we merge them. We'll repeat this process until we get one cluster. As shown in this figure, here A, B, C, D, E, F are the cluster, and we see that D and E are the nearest cluster. That's why we will merge them into DE. Similarly, B and C are the nearest cluster, and we will merge them into BC. Then next, in the lower part, we'll merge DE and F together as DEF. And from the upper part, B and C will come and we'll merge them into BCDEF. And finally, we'll merge with A to make ABCDEF. So this is how the agglomerative hierarchical clustering works. This is another visual representation of agglomerative hierarchical clustering. As I mentioned earlier, here A, B, C, D, E, F, G, H are the clusters, and here B and C will come merged to new cluster, that is BC, and D and E will be merging to DE, and F and G will be merging to FG. B, C and D will be merged to BCD, and here again A will be merged with BCD and to become ABCDE, and on the other side FG will be merged with H to get FGH, and finally it will become ABCDEFGH. This is how the agglomerative hierarchical approach is performed. The next is divisive hierarchical clustering, which is a top-down approach. So it starts with all points in one cluster and it repeatedly split clusters, and it ends with each point as its one cluster. So this method is less used because it is computationally expensive. Now let's see how it works. First, all data points it starts together, then we split the cluster into 2, and then we keep splitting until we get our desired cluster. So as shown in this figure, A, B, C, D, E, F, G, the top one will be splitted into FGH and A, B, C, D, E, and then A, B, C, D, E it will be splitted into B, C, D, E and A cluster. Similarly, FGH will be splitted into H and FG cluster. Here again FG cluster it is splitted into G and F, and DE will be splitted into DE individual cluster, and then BC cluster will be split into B and C, and then we have the A cluster. So this is how the divisive hierarchical clustering happens. So what is dendrogram? Dendrogram is a tree diagram which shows which clusters are merged and at what distance they are merged and how many clusters exist at different levels. So this is the figure of dendrogram. Here the data points A, B, C, D, E, F are all separated, which are at the bottom of the dendrogram. The closest points are merged into a single group as we go up, and the lines connecting the data points means how they are progressively merged according to their similarity. Next is the height at which they are connected. It shows how similar the points are. We choose the number of the clusters by drawing horizontal cut across the dendrogram. Advantages of hierarchical clustering. Dendrogram, it gives clear visual explanations of hierarchical clustering. It is better for small to medium datasets. There is no need to choose number of clusters in advance. It captures hierarchical relationship. It is easy to interpret results. Disadvantages of hierarchical clustering. Once clusters are merged, they cannot be undone. High memory usage. Choice of linkage can change results. Slow for large datasets. It is sensitive to noise and outliers. Applications of hierarchical clustering. Document and text clustering, gene expression analysis, image segmentation, market research and product grouping. Okay, that's all for hierarchical clustering. We understand that hierarchical clustering builds a tree of clusters. There are two types of hierarchical clustering. One is agglomerative hierarchical clustering and another is divisive hierarchical clustering. It uses linkage methods to measure cluster distances. And there is a dendrogram which helps to decide the number of clusters. In this video, we are going to see an example of how hierarchical clustering can be implemented in Python. So without wasting our time, let's get started. First, let's import the necessary libraries. So step 1 equals to importing the libraries. Import numpy as np. So this is for numerical data, and another is import matplotlib.pyplot as plt. This is for visualization, and from scipy.cluster.hierarchy import dendrogram linkage. So this is to create the hierarchical tree. Another is from sklearn.cluster import agglomerative clustering. So this is to form the final clusters. I'm sorry, here it should be small letter. Okay, after this, now let's create a simple dataset. Has step 2 is like creating a dataset. So x equals to np.array, and then I will give some data like 1, 2, 2, 3, and then 3, 2, and then let's say another is 8, 7, sorry, and then 9, 8, and then 8, 9, Okay, and let's close this. So here each row is a data point, and the first 3 points 1 to 3 are close to each other, this one, and the last 3 points like 7 8 9 are close together. So we expect that there are two clusters. Now let's plot this original data first. That's why step 3 is plotting the original data. I will write plot dot scatter and then x colon comma 0 and then x colon comma 1 and then s equals to 80. So basically we're trying to show the original data before clustering. And another is plot dot title and then original data, and next plot dot x label x-axis, and another is plot dot y label equals to y dash axis, and then plot dot show. Okay, so this will help us to understand the grouping of the data visually. Now next step is to create the dendrogram. So step 3 equals to creating the dendrogram. So linked equals to linkage x comma method equals to word. So here word, it minimizes the variance within the clusters, and another is plot dot figure and then figure size equals to 8,5 and then close this, and then dendrogram linked. So this dendrogram, it will show how clusters are merged, and plot dot title equals to dendrogram, and then we are doing the hierarchical clustering. Okay, and then plot dot x label is data points, and plot dot y label is distance, and then plot dot show. Okay, so this will create the dendrogram, right? Now next step is to apply agglomerative clustering. So step 5 is applying agglomerative clustering. Model equals to agglomerative clustering, and then I will give number of clusters equals to 2, linkage word, and then labels equals to model dot fit underscore predict, and then x. Okay, here we choose n underscore clusters equals to 2, and the model it assigns a cluster label to each data point. Next is to visualize the final cluster. That is step 6, and then visualize the final clusters. Plot dot scatter, and then x colon comma 0 comma x colon comma 1, c equals to labels comma c map equals to rainbow s equals to 80. Plot dot title, and then final clusters, hierarchical clustering, and then okay, plot dot x label, and then x-axis, what is that? Similarly, plot dot y label, and then y axis, and then plot dot so. Okay, I hope I have written all the code. So now let's run this. Oops, there is error here. Plot dot scatter, where this one, this one, right? Plot dot scatter x, I missed this one, this is capital. Okay, now let's save again and run this. Yeah, we get the result. So this is the original data. All the points, these points are near to each other, and these points are near to each other. Second, we had plotted the dendrogram. So this is the dendrogram of hierarchical clustering, and this is the final clusters. So here the points with the same color belongs to the same cluster, and it also conforms the separation as seen in the dendrogram. Therefore, this is the example of agglomerative hierarchical clustering. Today we are learning about DBSCAN clustering. So without further ado, let's start our video. So what is DBSCAN? DBSCAN, it stands for Density Based Spatial Clustering of Applications with Noise. It is unsupervised machine learning algorithm. DBSCAN groups data points based on density or how densely they are packed together, and it automatically detects outliers that do not belong to any cluster. Key idea behind DBSCAN. In fact, DBSCAN does not look at the distance to a center like k-means. Or we can say DBSCAN does not require us to specify the number of clusters beforehand. Instead, it asks, are there enough nearby points around this point? If it is yes, then it belongs to a cluster. If no, it is a noise. Therefore, this makes DBSCAN very powerful for real-world data. Parameters in DBSCAN algorithm. DBSCAN depends on two parameters only to detect clusters. One is epsilon and another is minimum points. Now let's learn each of them. EPS, epsilon. EPS defines the radius of the neighborhood around each data point. In simple words, EPS tells DBSCAN how close points must be to considered as a neighbors. Let's imagine drawing a circle around a data point. So, the radius of that circle is equal to the EPS. Next is minimum points. Minimum points decides how many nearby points are needed to form a cluster. It defines the density. So here the minimum points is 3. Points in DBSCAN. Core point, border point, noise point. So here minimum point shows the minimum number of points required inside the EPS circle. If a point has at least minimum points neighbor, it becomes a core point. Then core points form clusters. Points with fewer than minimum points neighbor may become border point or noise. Now let's see how DBSCAN works. We start with any unvisited point in the dataset. That is, picking a point that has not been checked yet. Next is finding all the points within EPS distance of this point, or look for nearby points inside the EPS circle. The third step is to check neighbor count. If neighbors are less than minimum points, then mark it as a noise. And if neighbors are greater than equals to minimum points, then mark it as a core point and start a cluster. The next step is to expand the cluster. First, add all the neighbors to the cluster. Then, for each neighbor, if it also has greater than or equal to minimum points neighbors, add its neighbor. Then, repeat the process until no more points can be added to the cluster. After that, move to the next unvisited point and repeat the steps from 1 to 5. Finally, we will finish all the steps of DBSCAN. And the points never added to any cluster, it remains as a noise. So this is how DBSCAN algorithm works. So these are the important points in DBSCAN. Advantages of DBSCAN. It automatically finds number of clusters. There is no need to specify the cluster centers. It detects outliers naturally. It is robust to noise. It works with irregular cluster shapes. Disadvantages of DBSCAN. It is not ideal for high dimensional data. It is sensitive to EPS value, and choosing parameters can be tricky, and there is struggles with varying densities. Applications of DBSCAN. Customer behavior analysis, geographic data analysis, fraud detection, sensor and IoT data, anomaly detection, image segmentation. Now let's learn when to use DBSCAN. We can use DBSCAN when we don't know number of clusters, or clusters have arbitrary shapes, or we can use DBSCAN when we expect noise or outliers. Similarly, we can use DBSCAN when the data is spatial or distance based. Now let's see the summary. We understand that DBSCAN is a density based clustering. It uses EPS and minimum samples or minimum points as a key parameters. Then it finds cluster plus noise, and there is no need to specify K in this method, and it is powerful for real world data. In this video, we are going to implement DBSCAN in Python. So let's start our video. Now let's import the libraries first. As importing libraries. Import numpy snp, import matplotlib.pyplot is plt, and then from sklearn.cluster import DBSCAN. As I have explained in every video that NumPy is used to create numerical data, matplotlib is used to draw the scatter plots, and here DBSCAN is the clustering algorithm. Next step is to create a dataset with some noise. So let's create dataset, create a data set. So I will give x equals to np.array, and I will give some data, 1 comma 2, 2 comma 2, and then 2 comma 3, 3 comma 2, and let's say 3 comma 3. Okay, let me assume this is a cluster 1, and I will give another cluster like 8 comma 7, and then 8 comma 8, and then 7 comma 8, and then 9 comma 8, and then let's say 8 comma 9, 8 comma 9. Okay, this is cluster 2. Then I will give some point which are far from the 1 and 2 like 20 comma 20, and then 22 comma 22, and okay, these are noise points or outliers which are a bit far away. I think this dataset is perfect to understand DBSCAN. Now let's apply DBSCAN algorithm. As applying DBSCAN algorithm, and then I'll write DBSCAN equals DBSCAN, and then I will give the EPS equals to 1.5, and mean let's say samples equals to 3. So here EPS equals to 1.5 is the radius around each point, and the points within the distance of 1.5 are considered as neighbors. Another is minimum sample equals to 3, means at least 3 nearby points are required to form a cluster. Next is labels equals to dbscan.fit, and I'll predict and x. Okay, this fits the DBSCAN model and predicts the clusters. Now let's understand what is label here. So knowing the labels, so I can print labels. Let's run and see this one. Does not match the opening closing parenthesis, does not match with the opening parenthesis. Okay, oh, I missed here. Okay, now it's okay. Yeah, see, we get this. Here 0 means cluster 1 and 1 means cluster 2 and -1 it means noise or outliers. Therefore, DBSCAN it automatically find like 2 clusters here and 2 noise points. So there is no need to tell the number of the clusters over here. Now let's visualize the result. I will write here again. So visualizing the result, and I'll write plot dot scatter, and I will zero and sorry and x comma 1 c equals to labels comma c map equals to, let me write rainbow, and then yes comma yes equals to 80, close this, and then I will plot the title as DBSCAN Clustering, and plot x label equals to x, and then plot dot y label equals to y, and then plot dot show. Okay, now let's save this and run this. See, each cluster it has one color, that is green, and then red, and this purple, and noise points, it appears in different color, that is purple, and here we can see there are 2 dense cluster and one is isolated noise points. So DBSCAN performed its algorithm internally and we see this result. Therefore, we understand DBSCAN is a density based algorithm and it uses like EPS and mean points. It can find clusters and noise, and it is better than k-means clustering for messy data. In this video, we'll learn about overfitting and underfitting in machine learning. So without further ado, let's get started. Now let's understand what is underfitting and overfitting. When we train a machine learning model, we want to create a model that can predict accurately for new data. In order to test our model's performance, we split our data into training set and testing set. Training dataset is used to train the model, whereas the testing dataset is used to evaluate the model's performance. However, sometimes our machine learning model fails to make an accurate prediction, and this is due to underfitting or overfitting problem, as model learns either too much or too little. Therefore, to make a good model, we must be careful to find out the right spot. What is underfitting? Underfitting occurs when a model is too simple to capture the underlying structure of the data. That means the model has a high bias and it fails to know the relationships between input and the output features effectively. The graph of underfitting goes like this. So as shown in this figure, the output result is so simple. That is a kind of a straight line. So it fails to capture the complexity of the data and it misses the data. Therefore, it has large errors on both training and the testing dataset. The key features of underfitting are: it has low training accuracy, low testing accuracy, it has high training error, and the model predictions are so simplistic, and underfitting occurs when there is a high bias. What is overfitting? Overfitting occurs when the model learns the training data so well, including noise and outliers. That is like the model memorized the training data instead of recognizing the patterns in the data. Therefore, it leads to poor performance to new test data. This happens due to high variance in the model. This is the graph of overfitting. It has high variance. Here, the model captures every training data point. Therefore, it is complex. Instead of capturing the true patterns, it also captures all the noise or the outliers. Key features of overfitting. Overfitting occurs when the model is too complex. When it has poor generalization, that is, it captures noise and outliers instead of true patterns in the data. Next is it has high variance and the model has too many features. So these are the characteristics of overfitting. The bias variance trade-off explains why underfitting and overfitting happens. High bias underfitting. So underfitting mainly occurs due to high bias. High bias means model makes strong assumptions about data and it fails to capture the patterns. Variance is low here because the model gives similar kind of outputs even if the input data changes. Therefore, underfitting it is equals to high bias and low variance. High variance overfitting. Overfitting is mainly caused by high variance. High variance means model is too sensitive to small changes in the data. It learns noisy patterns. It has low bias as the model is too flexible. Therefore, overfitting is low bias and high variance. Hence, from this we can understand that a good machine learning model is an optimal balance between bias and variance. Here is the underfitting, good fit and overfitting graph. And good fit curve means that it captures the data trend as well as it avoids the excessive complexity. So in good fit, it has a low bias and low variance. How to fix underfitting? For underfitting, we can increase the complexity of the model. We can add additional new features to improve learning. And if regularization is too strong, then it may simplify the model overly. Therefore, we should reduce the regularization. Next is some models may require more training period in order to learn patterns more effectively. So we have to train the data for longer. Last one is we can scale the features properly. How to fix overfitting? We can use more training data. We can apply regularization. We can perform feature selection. We can use early stopping. There can be cross-validation. We can simplify the model. Okay, that's all for overfitting and underfitting in machine learning. We understand that overfitting and underfitting are not useful for good machine learning model. Therefore, the goal is generalization and hence the bias variance trade-off is an important part for machine learning model. And a good machine learning model is one that performs well on an unseen data by balancing both bias and variance. In this video, we are going to learn about evaluation metrics in machine learning. Now, let's dive in. Evaluation metrics in machine learning. After we build our machine learning model, it is equally important to evaluate the performance of the model correctly. For that, we use different evaluation metrics for different types of problems in machine learning. Types of evaluation metrics. There are three types of evaluation metrics. One is classification metrics, another is regression metrics, and next is clustering metrics. Now let's see each of them. In classification metrics, we have different evaluation metrics such as accuracy, precision, recall or sensitivity, F1 score. Now let's discuss each of them. Accuracy. The formula for accuracy is the number of correct predictions divided by total number of predictions, and it measures overall correctness of the model. The main advantages of using these metrics is it is useful when classes are balanced, and the limitations are it fails in imbalanced datasets as it assumes all errors are equally bad, but in reality this is not true. Precision. The formula for precision is precision equals to true positives divided by true positives plus false positives. And the measures is precision gives an answer to the question like when the model predicts positive or how often it is correct. And the use cases for this is precision is used when the false positives are costly. For example, spam detections or fraud alerts. Recall or sensitivity. The formula for this is recall equals to true positives divided by true positives plus false negatives. Meaning, out of the positive cases, how many did we detect? That means recall measures how many actual positive cases the model successfully captured. The use case of recall can be when false negatives are dangerous. That is like in detection of disease such as cancer detection. F1 score. The formula for F1 score is 2 into precision into recall divided by precision plus recall. Meaning harmonic mean of precision and recall. That is, the F1 score balances the precision and recall using the harmonic mean. Use cases. We use this matrix when we need a balance between precision and recall. For example, spam filters. Next evaluation matrix is regression matrix and it can be divided into mean absolute error MAE, mean squared error MSE, root mean squared error RMSE, R squared or coefficient of determination. Now let's see each of them. Mean absolute error MAE. This is the formula for mean absolute error. Mean absolute error is the average absolute difference between actual and predicted values. The use cases can be in the house price predictions. Advantages. It is easy to interpret. Disadvantages. This matrix treats all errors equally. Mean squared error MSE. This is the formula for MSE, meaning the average of squared difference between predicted and the actual values. The use cases can be when large errors are highly undesirable. For example, in stock price forecasting. Root mean squared error or RMSE. So the formula is square root of MSE. Therefore, the meaning of RMSE is the square root of MSE and it brings error back to the original unit scale. The advantage of using this matrix is it is easy to interpret and it penalizes the large errors. R squared or coefficient of determination. The formula is like this, meaning it measures proportion of variance explained by the model. The advantages of this is it explains variability in the data. Disadvantage is it is not good for nonlinear models. Next is clustering matrix, that is silhouette score. Now let's see what is silhouette score. The formula for silhouette score equals to B minus A divided by max of A and B. A is the average intra-cluster distance. B is average nearest cluster distance. The meaning this measures how well data points are clustered. And the use cases is like in customer segmentation. Matrix selection guide. Evaluation metrics quantify model performance and choosing the correct matrix is always important part. Therefore, here are some of the examples. For the problem like balanced classification, we can choose accuracy matrix. For fraud detection, we can choose precision matrix. For imbalanced classification, we can choose either precision or recall or F1 score matrix. For business forecasting, we can choose MAE. For regression, general type, we can choose RMSE. For medical diagnosis, we can choose recall. Therefore, first we have to find the type of the problem and then we can choose the appropriate evaluation metrics. Okay, this is all about evaluation metrics. We understand that no single metric is universally the best. Sometimes accuracy can mislead and we should align metrics with our objective. Hence, choosing the right metric is as important as building the model itself. Okay, that's all for today. We have learned about all the fundamentals of an artificial intelligence, such as tokenization, fine tuning, RAG, hallucinations, and so on. Similarly, we have learned machine learning topics like regression, decision trees, random forest, GAN, and so on. I hope you like this video. If you think this video is really helpful, please do not forget to like, share, and subscribe my channel, and comment down if you want me to cover new topics. Thank you for watching. I will see you in the next episode.